our channel, that is AI next generation. So in this particular video we are going to see about the PyTorch, the basic about the PyTorch. In this particular series we will see how the PyTorch we are going to use in the case of images, in the case of data, and what are basically the PyTorch. So I will just upload the series of the videos in this particular on the topic of the PyTorch. But this particular video is only the basics, you know, about the basic of the PyTorch. If you don't have any zero level knowledge of the PyTorch, so you can just start from this particular video. Okay, so basically why we are going to use PyTorch. So in deep learning there are two type of mainly famous library nowadays. One comes the one that is the TensorFlow, that is used on top of the Keras, and the second is the PyTorch we are going to see today now. So what the main difference between the PyTorch and TensorFlow is? So TensorFlow you can just consider as a high level API, that is user friendly API, but PyTorch is basically the low level API. But the plus point of the PyTorch is that you can just use many tuning part you can just do in the PyTorch. Okay, for debugging part it's really better as compared to the TensorFlow. So you have some merits, you have some demerits of the PyTorch, also you have some merits and demerits of the TensorFlow also. So it's nowadays you can just think, if you are really know about the oops concept, you are really advanced in the Python concept, so you can directly go to the PyTorch. Okay, so if you are coming from the machine learning background, like machine learning you have completed SVM, KNN and all sort of things, and you want to shift again in the deep learning, so for that you can just start the TensorFlow. Okay, but in that particular it does not make any sense. You should learn PyTorch, or either you should learn the TensorFlow, but you should stick only the one particular deep learning library. So it's not that PyTorch is really fast as compared to the TensorFlow. The speed is almost for the PyTorch and TensorFlow is same. Even the, if you'll say the PyTorch will give you the more accuracy as compared to the TensorFlow, it's not like that. Its accuracy will be almost similar. Okay, so the basic difference is that their path is different, but their goal is the same. Okay, so in this particular video we will see of the PyTorch, who want to who are more interested in the particular PyTorch in the deep learning library, and why PyTorch is widely used. Now you can just compare within last year or 2 years. So PyTorch is really highly growing deep learning library as compared to the TensorFlow. Okay, so you can just, because PyTorch is really looking you can just say that it's a low level API, and where you can just do so many debuggings. Okay, you can just do works on the low level, you can just build your own class, your own data set, custom data set. Okay, so you can just do lots of things with the help of PyTorch. So particular video we are going to see the basics about the PyTorch. So what the first thing is that why Python? So basically Python based scientific computational library, that is the PyTorch, is based on the Python, it's advanced Python. Okay, so whenever you are comparing with the Numpy, either you can just create everything with the Numpy, you can create a neural network, artificial neural network with the help of Numpy, but in that case they are not using GPU. You have to use something GPU to speed up your speed. Okay, so why we are using GPU as compared to the CPU? So Numpy they works only on CPU, but whenever you want to build something that works on the GPU, that is the PyTorch. Facebook they develop their deep learning library, that is the PyTorch. Okay, so that is the replacement of the Numpy. So that particular Numpy you are just using the GPU, they are called as a Tensor. Okay, that is PyTorch. Okay, so basically you can compare whenever you are just training a, suppose 50,000 or 60,000 total images for the training period, and you are using CPU, it will take hardly, it will take 6 hours or 7 hours to train that particular model. Okay, but whenever you are using GPU in that, it hardly takes 5 you can just take 30 minutes or 30 to 1 hour, hardly it will take. Okay, so that is the power of GPU. So you are just you are just decreasing the training time. Okay, that is the plus point you are getting. Also you are just seeing some accuracy. Okay, and metric multiplication is really fast as in the GPU as compared to the CPU. Okay, so that's why it's in replacement of the Numpy. Okay, and the second thing is that it is really fast. Already I have just said to you, it's like flexibility, and it's really fast as compared to the CPU. And whenever you are comparing with the Numpy, so Numpy only works with the CPU, and whenever you want to work something works in the GPU form, then you have to move to the PyTorch. Okay, so that was the basic concept of the PyTorch. Then we will just jump to the coding part. In that we will compare with the Numpy. Okay, so how you have doing the coding in the Numpy? Okay, so same way we can just do the coding in this particular PyTorch. Okay, so I will just write you how to import this basically PyTorch library. So you can just directly write import torch. Okay, so if you have not downloaded this particular torch, okay, what you can just do, you can go to their official website PyTorch, and then after it will be there. Okay, you can just directly download from that particular website. This is the website and it will just show you somewhere. This is the website. Okay, so basically if you are using the CPU, if you are using the GPU, you should download the GPU version. Okay, so what here you can just go for, if you are using Conda, so what you can just do, so is the for I'm just using the Mac OS, so it does not support the CUDA, so I have only the CPU. So whenever your system has the GPU configuration, what you can just write, what you have to select Linux, Mac or Windows. Okay, so if you are selecting Windows, then after you are selecting, you are just downloading from the Conda Anaconda environment or simply command prompt. Okay, you can just select this one, that's a really the same, and here you have to just copy this particular command. Okay, so you have to copy this command and you have to paste in the Conda, okay, Anaconda prompt, or whether if you are going for the pip, then you have to just write for this. Okay, this you have to just paste in the command prompt. Okay, CMT. So this is really how you can just download, it will just download the GPU version. Okay, so if you want to download only the CPU version, you can just write this one. Okay, so it's depend upon you, your system, you have to check whether your system supports the GPU or your system does not have the GPU. Okay, so you can just download from here. So now let's move to the forward. How to import this particular PyTorch? You have to just write import torch. That's it. Okay. You have this particular is a PyTorch library where it will just import this particular torch. Okay. Then after that, what you have to just write, if I will just say you the basics of the PyTorch. Okay. So as compared to the Numpy. Okay. So in Numpy we are just calling as a array. Matrix we are calling as a array, but in particular PyTorch we will call as a tensor. Okay. So this thing I can just write so it will not make you doubts. Okay, so what I was speaking about this, in PyTorch what you are just saying, in PyTorch you are going to say in PyTorch the matrix. Okay, the matrix or the array. Okay, matrix and the array we are just saying that are called as a tensor. Okay, as tensor. So this particular PyTorch, basically in the matrix or the array in the PyTorch they are called as a tensor, but in the case in the Numpy you are calling as a array or matrix. Okay, that is really simple. So this thing, and how to even you can just import Numpy so that we can just compare that thing in the parallel. So it will be like really easy for you, so that if you are from the Numpy a particular background, you know that Numpy, if you are just learning the deep link, I think you should know the Numpy and pandas concept. If you don't know, then I will just keep the link in this video description. You can just read from that particular website. Already I've just written about the Numpy. Okay, so what you can just write here, import Numpy as np. Now if I'm going to say whether if I want to say you have to create an array. Okay, Numpy array you have to create. How you are just creating in the Numpy, you are just writing now, you are just writing, suppose np dot array, I'm just taking a variable, and you are just writing np dot, what you are just writing, np dot array, what you are just writing in this particular Numpy array to create a matrices of 2 dimension, like 1 2 3. Again you have to pass everything in the list, and then after the second thing what you have to pass 4 5 6. Okay, again you have to pass in the list. Okay, so you can just create, this is the Numpy array you have just created. Okay, this is how you are just creating in the Numpy, but how you have to create this particular thing in the tensor PyTorch. Okay, the similar way you can just control, already I have just said you, in the Numpy you are calling as a np.array, but in particular PyTorch you will call as a tensor. Okay, you will call as a array or matrix as a tensor. Okay, that particular thing works on the GPU. So what we can just do, what you can just do, you can just write the basic concept, that is if you want to create the particular, if you want to see the shape also, you can just do the shape, or no need to for this shape. Now you have to create the tensor. Okay, so how you will just create the tensor, you can just write tensor. Okay, tensor. Okay, and here what you have to write, torch dot tensor. Okay, you have to write torch dot tensor, and then after you have to pass this particular, and here you have to pass this particular array. Okay, which particular array, already you know that you can just pass within the two list. Okay, you already have the array 1 comma 2 comma 3, and then after the second array we have created 4 comma 5 comma 6. Okay, now you want to see this particular tensor. Okay, how it looks, so it will give you as a See, this is how it, by default their data type is the float data type for particular tensor. So this is the particular tensor. You are just creating the tensor, you are just creating the array, okay, in the numpy, and the python you are just getting as a tensor. So I don't think so you will have doubt in the basic concept. The shape of both will be the really similar, okay. So like shape, if you are going for the shape, it has 2 rows and 3 columns. It has also 2 rows and the 3 column, okay. So that was the really easy case. Even if you want to see the numpy ones or numpy zeros, okay, so what you can just write here, if I'm just saying you have to write torch ones, you are just getting the ones matrix, okay, ones matrix or tensor you can just say. And in once you can just write the tensor, we are already sticking with the same thing, okay. So how you are going to use in the numpy array, you know that how you are just getting the ones matrix, you are just writing np dot ones and you are just passing the parameter, that's it, you are just using the this. So this how you are just getting this particular numpy. The similar way you have to create in the tensor. What you will just write here in the torch, you will just write here torch dot ones, okay. You can just write torch dot ones, and then after that you will pass the parameter 2, 3, okay. That's how you will pass. So this how it will return the same. You can just do the initialize. This particular we are using for the zeros or ones for the initializing of that particular. Whenever you are going for the use of RNN or CNN, I will just come up this thing in the later topic. The here you have to just understand the basics about this, okay. So I don't think so you have doubt till now in there. So the next thing what we can just do, so if you are just creating any numpy, okay, so you already have created the numpy. So if you are creating the numpy, but what you want to do, you want to change that particular numpy to a tensor, okay, or you want to change the tensor to back to the numpy, then how you will just use, you can just use the concept, or what I can just write the first, what we will just go, we will change from numpy to the tensor, okay, from numpy to tensor. You can just create this one. Then how, what you will just write here, you will just write, you will just create an array, okay. You will create some first numpy array, okay. I'm just creating a numpy array, np dot array, and here I'm just passing in the list this one. I'm just writing the same thing, okay, 1 comma 2 comma 3, and then after you are just creating more list 4 comma 5 comma 6, okay. So you can just hold some in the one more list that you are just creating the 2 dimension, okay. Then this is the particular numpy array you have created, this is the numpy array, but you want to convert this numpy array to a particular torch, okay. Then how you will just convert this particular to a tensor, okay. So for that what you have to use, you have to use the from numpy, okay. So torch dot from numpy will convert your numpy array to a torch tensor, okay. This how you will just convert. How you will just do, I can just write a numpy to torch, okay. I'm just getting the variable. Then what you can just write here, torch dot from numpy, you can just write here from numpy, okay, from numpy, and it will just give you, see, it will just, and here you have to pass this array, okay. You can just pass this particular array and just run this one, okay. So you will see you have converted this particular torch to a numpy to a torch, okay, torch tensor. So this how we can just think, you can just see this particular numpy to torch and run this one, okay. This particular has been converted into tensor. So you are just, how you are just converting from numpy to a tensor, I think it's clear to you. Then again, what you have one more concept, you have to convert from, now you already know that you have converted from numpy to tensor. Now you have to convert from tensor to numpy, back to the numpy again, from tensor to numpy, okay. You can just do the same thing. What you have to just, you already have the numpy to tensor, this is your tensor, okay. Numpy to torch, numpy to torch variable holds the tensor, okay. Now you have to convert this tensor to back to the numpy. Then for that what you can just write here, you can just create one more variable, tensor to numpy, okay. Numpy you can just write here, what you can just do, call this particular numpy to torch, okay, and just write here, you have to just write here numpy, that's it, dot numpy you can just write here, okay. And just see how it has been converted or not, okay. Tensor to numpy, I think they are really easy, okay. So here you are seeing that you are just getting this particular in the array form, here you are getting the tensor form, okay. So now it's clear how you have to convert from tensor to numpy or numpy to tensor, okay. So this was the really basic important concept. Now we will jump to the basics maths in the PyTorch, okay. So what basic operation maths in the PyTorch, like we have to just how to add, how to subtract in particular torch, okay. We already have this seen in this particular this thing in the numpy, okay. So it will be like really easy for you. So I think it's like really easy. Then what you can just do, first of all we will see the reshape. Okay, how to do reshape. Okay, how to do reshape of this particular torch. Okay, so first of all create any tensor. Okay, just create any tensor. You can just write anything, and here just write torch. I'm just creating the ones tensor. Okay, so ones tensor like 3 or 4 comma 4 I'm just creating. Okay, this is what I'm just creating. What you have to write after that, you know that you have just created four matrix. You can even see this one. Okay, so if you have it out, you have 4 rows and 4 columns, ones of this how you are just creating ones matrix. Okay, that has 4 rows and 4 columns. Okay, so now what you want to do, resize of this thing, you want to shift this particular to 8 comma 2. Okay, what you can just do, in this particular you have view. Okay, you have view to resize this particular. So in this particular numpy, what you are just using, you are just using the concept of reshape or reshape. But here what you will use in the tensor or PyTorch, you will use the view. Okay, so view is basically used to resize your tensor. What you can just write here, you have to just give that particular thing 2 comma 8. I'm just writing this one. I will show you one thing more about the -1, but again just stick to ones. You have just resized this whole 4 comma 4 into 2 rows and 8 columns. You don't have any doubt, you can just use view to resize the tensor with the help of in this particular PyTorch. But what if I just write -1 comma 8 -1 comma 8? So what it will just write, it will give you the same output. It will give you the 2 rows and 8 columns. Why? Because when, and if I'm just writing 8 comma -1, I'm explaining you first. If I'm just writing 8 comma minus, it will give you 8 rows and 2 columns. Okay, so what does it mean? So -1 in this basically a PyTorch, it is, you are saying that PyTorch to figure out that you know that you have 8 columns, you know that you have 8 columns, you know that you are creating 8 rows, and let PyTorch to figure out how many columns they want to keep. Okay, you are saying that I want 8 rows, that's my fix. Okay, now the -1 basically say that you are saying to PyTorch, okay, to you should look out how many columns you want. Okay, look out by the PyTorch. Okay, the PyTorch. So I don't think so you have doubt in this. These are really simple concept. So then after that we will use the adding subtraction that are really simple. What you can just write, torch dot, not tensor, torch dot, we can just write torch dot add, to add this particular array. What you can just write here, tensor comma tensor. Okay, so you don't have it, you just add this one. This how it has been added. Then again similar, you can just write here torch dot subtracting. You have to do subtract. You can just pass here tensor comma tensor. Okay, just pass the same thing and just run. It will give you the 0 0. Then similar, you can just go for the multiplication. I know they are really easy, I no need to explain this one, but you have to know the basic syntax of this. Okay, and again you can just run multiplication of this, and then after you have one more, that is division of that. Okay, then torch dot div. Okay, the torch dot div, if you are just dividing this particular thing, so how we are just right here, just pass the same thing. You have to just pass the tensor what you have just created comma tensor. Okay, tensor. Okay, so now you'll see you will get this output. And if you want to know the mean of that particular tensor, you can just write torch dot mean. Okay, that's it. It's like similar thing what you're using in the numpy. And if you want to know the standard deviation, then write torch std. Okay, so this how you have to know the standard deviation or numpy or mean of that. Okay, so that's why this is the basic math behind the tensor. What you are going to see, this is the common thing you will going to use. Okay, so now again the one thing more, that is the concept of the variable. Okay, so this will be the last of this particular basics of the PyTorch, that is the variable. So variable is what? So variable is basically that accumulates the gradient. Okay, so accumulates the gradient, that holds the gradients. Okay, whenever during the back propagation, what you are just doing, you are just updating the weights. So you are reducing the cost function. Then how you are just reducing this cost function? Okay, so I will just write, first of all I will just write variable. Okay, which accumulates the gradient. Okay, so basically what I am saying, that whenever you are just training a model, so during the forward propagation you are just calculating the loss. Okay, we will see again in the later topic. For now just understand, during the backward propagation what you are just doing, you are just updating the weight and you are just reducing the cost function. Okay, so what you have to hold some, you have to calculate the gradient. So that whole variable, that's whole the gradient. Okay, that's why you are using the variable in this particular PyTorch. Okay, so what we can just do here, you can just how to import this particular, you can just write from torch dot auto grade. Okay, you can just write here or torch dot auto grade, and then after you have to import variable. Just run this one. Okay, this already has been run. What you have to just define some, we can just define any variable. Okay, we are just defining the random variable that what we have already have just imported this library, and you are just getting torch dot ones. I'm just sticking to ones only. You are creating a one dimension array. Okay, and then after it's like one dimension tensor you are just creating, and then after what you have to write, you have to pass the one more parameter, that is the requires grades. Okay, so what does require grades is means? So require grades is, you are saying that whether you want to differentiate this particular, you want to calculate the gradient of this or not. Okay, you have to pass this true. Okay, by default it is false. Okay, so you are just creating this particular variable and just call this one. Let's see how it look. This is what is the required grades means. You are just calculating the gradient of this particular torch dot ones. Is basically means you are just holding the gradient, that's it. Okay, what you are going to use. Okay, so what you can just do, if you are just doing the differentiating of this particular, okay, suppose you have just so suppose you have the equation of y equal to s square, you can just say, and if the differentiation of that will be what, 2x. Okay, so y square, you have the equation that is the y power f, so you are just writing y power 2, and after differentiating of this will be the 2y. Okay, this is how it will just differentiate now. So this is basically how you are going to see in this particular variable. So it will holds the gradient, what you are just calculating, what you are just getting after this, it will just hold as particular gradient. Okay, so what we can just do, even we can just create an array, so you will be more clear with that. So I will just create one array, and here you can just pass 2 comma 4. Okay, this I'm just getting random 2 comma 3 or 2 comma 4, you can pass anything. And again we are just creating a tensor. Okay, torch dot tensor, and you are just basically means you are just writing this one array, you are just converting this particular array. You can pass here also, it does not make any sense. Okay, you can just keep this for now. Okay, even you can just hold, no problem. Okay, so now you are just using this one. Now you have to convert this particular into variable. Now I'm just going to step by step. Okay, so you are just writing x. Okay, x contains the variable that what you can do, you are just saying that required grade equal to true means you are just calculating the differentiation of this. Okay, derivative of this. Okay, then you have to pass this particular tensor what you have just created of. Okay, tensor, and then after that you have to say required grades equal to true. Okay, required grade equal to true. Okay, that's true. And then after that what you have to just, you have to write the, this is the x, what variable you are just passing. Then after you have to find the equation. This is your equation, suppose this is your equation x square. Okay, what already I have said you. So whenever you are writing this one, okay, so if I'm just printing this particular x, then what will be the output? See, if I'm just printing this particular y, sorry, y I'm just printing, so what will be the output? See, so 4 comma 9, you are just passing this particular 2 comma 3 in this equation, and you are getting square of 2 and square of 3. Okay, so then after that what you are just doing, you want to do the differentiation of this. Okay, how you will just do the differentiation? Okay, so you can just do, you already have the x square. Okay, so what you can just do, you can just write the same as it is, o equal to 2x. I'm just writing this really even what you can just do, if you have some equation, suppose you have some equation, and what you can just write here, you can just create 1 comma 2, and then after you are just going for the particular calculating the sum of that. Okay, you can just write this sum of, and particular y we are calculating for the sum of this y. Okay, is how you can just go, because this is the equation you are getting na, means x square, and if you are writing this thing into 2x, this will be the approx equal to s square. Okay, so it's basically you are just differentiating s square. Okay, with respect to dy by dx, you are just differentiating, you are just derivating of y with respect to x. Okay, that's what you are just doing. Okay, that what you can just do, you can just use o dot backward. Okay, this is your equation, this is your, suppose this is your gradient equation. Okay, or what you can just think, suppose this is your equation. Okay, this is your, basically this is your equation, y equal to x square. Suppose you are using this particular a loss function, suppose you are using the loss function. Okay, so whenever during the deep learning, what you are doing during the back propagation, you are just updating the weights. For updating the weights, what you are going to use, you have to just, you calculate the gradient, and you are just derivating of loss with respect to that particular weight. Okay, so you have to just change the weight, you have to give with particular weight, and how during the back propagation you have to just change the weight. Okay, so what o dot backward, it is what it is doing, it is just calculating the gradient, that's it, calculates the gradient. Okay, it just calculate the gradient. So I don't think so you will have any doubt in this. Okay, so what you can just do, you can just run, even you can, I want to print this particular gradient. Okay, you want to see this particular gradient, what you can just write it, already we have x dot grade. Okay, but this is the automatic grade, it will just calculate. Let's see, this is what was the output. So 2 comma 3, basically that is your gradient, we are just going to calculate gradient tensor. Okay, so this was the really basic concept. So it's basically you will get more clear whenever you will do the coding part. I know it will be like quite like 1% complicated for the variable to understand you, because you have not implemented till now the back propagation. Again, I will do in the this thing in the coming video, so it will be like more clear whenever you will do the real world problem. Okay, so this was the basic concept of the PyTorch, why we are going for the PyTorch, how it is different from the TensorFlow, how we have downloaded the PyTorch, how to import the PyTorch, and we have just compare with basically with the Numpy. So you are, if you are expert in the Numpy, so it will be like quite easy for you to understand this particular PyTorch. You know how to create the once matrix, two matrix, and then after you know how to convert from TensorFlow to Torch, from Numpy to Tensor, or back to the Tensor to the Numpy. You know, you have done the basics maths about how to add, subtract. I know they are the really basic. And then also you have just gone for the variable that accumulates your gradient. Okay, that's whole your gradient. Okay, that was the really basic concept in the PyTorch. In the next video we will see again that's related to the PyTorch. We will use how we have to know about the data loader, data state, custom data set, how to train the model, how to evaluate the model. So they are really basic, there are really many things in this. So we will see this all thing in the coming video. Hope so. If you like this video, please subscribe our channel. Thank you. To our part 2 video of the series of the PyTorch. In the part 1 you already have seen the basics of the PyTorch, why we are using PyTorch, what is the difference between the NumPy and the PyTorch, and basic operation you have done in this particular in the first video. Now we will jump to the second video that will be related to the data. So data means basically how you are just importing the data, how you are just downloading this data set, how you are just using the concept of the data loader, and how you are just visualizing that particular data set. Okay, these four things we are going to see in this particular video is basically the really basic concept. If you are really know this type of concept in this whole PyTorch series, you will able to do more advanced problem. Because if you are really beginner in this PyTorch series, then you are here and you can just learn from this particular video. So what we are going to use, we will take an data set that is the MNIST data set. We will take an example from their MNIST data set. MNIST is basically handwriting digit recognition. Okay, so it's basically you have 0 to 9 digit and you have to say whether the particular digit is 0 or 1 and 2. You have to build that particular model, but that data set already has been present in the Torch Vision library. Okay, so we will see, first of all we will see the different type of library we are going to use, how, and then after that we will do some we will download this particular data set. Then after we will use data loader concept, everything I will explain you in detail, and then after we will visualize this data set. Okay, so how we are going to use. So here what we are going to use, first of all, if you have just seen in the part 1 video, we have imported the torch. Okay, so already you know this one, import torch. But the second thing we are going to use, import torch dot nn as nn. Okay, so what does it mean? Nn is basically means you are just importing neural network. Okay? You are just importing neural network, that's it. Okay, you are just importing the neural network from this particular torch, and then after that what you have to import, you have to also import the optimizer. You say import torch dot optim. You can just write now as a optim. Okay, from here you can, what you can just do, you can just directly import that one. That is if you want to use a stochastic gradient descent, or whether you want to use Adam optimizer. Okay, so we will just, whenever we will just create the model, then after we will define the loss function, and then after optimizer, at that time I will show you. Okay, so here what you can just do, you are just importing the basic library, and it is, I'm just saying the basic concept of this. Okay, so this is the, here you have to, here you are just getting what I'm just writing, here you are just writing optimizer. Okay, this is the optimizer. Then after that I will explain you, then after that you have to import the data loader. Okay, so what do you mean by data loader? Data loader basically we are going to use whenever you are just modifying, whenever you are just dividing your data set into a batches form. Okay, so you have 100 total of images, you want to divide that whole images into 10 batches. Okay, and per batches you have 10 images, then we can use with the help of data loader. And the second thing, you can also use the data loader as a shuffling part, means the random image you can just take, and then after you are just going for the training the model, and also you are just preparing the data set so that you can directly fit into the model. Okay, so what we can just import from torch dot, it is present in torch dot utils data, utils dot data import data load. Okay, so I don't think so you have any doubt till now. Okay, this is what you have just imported there. And then after that, even you can just import the one thing that is related to the data set also, you can just import, it is present in the same thing. Okay, so data set is basically that, I can explain you about the data set, but now we can just do one thing. We have to just focus one more library, that is a torch vision library. So torch vision library that works parallel in the torch. Okay, torch vision, basically you have to just import torch vision, that's it. Okay, and if you don't have this library, just import pip install torch vision. So torch vision is basically used for the computer vision library. Okay, whenever you are just doing the deep, whenever you have chosen PyTorch as a deep learning library, and at that time you are just doing the problem related to the computer vision. Okay, you are just doing some experiment related to the computer vision, at that time you have to use torch vision library, because here you can just do many multiple transform of that particular image, you can just resize, you can do image augmentation, you can do with the help of torch vision. Even the pre-trained model, you already have the pre-trained model that you will see in the CNN concept, so that is really different, like resonate inception, that already it is present in the torch vision library. Okay, so what you can just do here, you import this particular torch vision, and then after the data set we are going to use MNIST data set, that also it is present in this particular video, in this particular torch vision. Okay, so what you can just write here, import torch vision dot, so first of all we will just use the data set. Okay, data sets. Okay, as data set we can just write, okay, it's no problem. And then after that, what you are going to use, import transform. Okay, transform is basically means that you want to transform that particular image to a multiple, either you are doing a resize of that, either you are doing augmentation of that, either you are doing horizontal flip, vertical flip, they are the concept of the image augmentation. Okay, so we can, even we will see this thing in the later on, but here now you have to concentrate how you are just importing the library and how you are just pre-processing this data set, downloading the data set. Okay, then what you have to just write as transform. I don't think so you have dot till now, it's like really easy. And then after, even one more library we are going to use, that is a matplotlib. Okay, to visualize the data set. Okay, so I think this much library is really enough for you. You can just use this particular library. The second step we are going to use, that is basically downloading the dataset. That MNIST dataset that already I have said you, it is present in this particular, in this particular torch vision. What here you can just mention, we are going for the MNIST. Okay, so it's basically, this is the basic MNIST PyTorch. You are just using MNIST dataset to recognize the digit using PyTorch. And this PyTorch, I'm explaining you the basic concept, so that you are able to, if you are really beginner in the PyTorch, so you already have just finished the first video, and if you are moving to the second video, it's like really good, and you will just see how the step by step you have to process to implement the deep learning, PyTorch deep learning basically. Okay, the second thing, if you are just, you want to download the data set, what you can just do, the first we can just define train set, and then after that you have already this particular data set, it is present. Okay, so what you can just do here, you can just write this particular data set here, it is already present, and from where we have to just write the data set, you have to select this particular MNIST. Okay, so you have basically lots of data set. It's like Celtech, it says CFAR10 data set, you will have Coco data set, you will have Flickr data set, you will have. Okay, so you have to just use the MNIST data. Okay, so MNIST data, you can have any number of sorts of data sets. Okay, I'm just taking the now for example as a MNIST. Okay, so now after that, what you is take the 4 parameter. Okay, is take the 4 parameter, the one parameter it will take as a basically the root. Okay, where you want to download this particular data. Okay, so the first parameter will take the root where you want to download this data set. Okay, so you can just provide the data, the path. I am just keeping the same directory, so no, I am not providing the path. And then second parameter, it will take the train. Okay, the train, whether you are just downloading this data set for the training, or whether you are downloading this data set for the testing. Okay, yes, you are just downloading for the training, just write here true. Okay, then the third parameter what you can just take here, you will just take a basically transform. Okay, transform, what you can just mention, what you can just mention the transform you already have said. If you want to divide, if you are just transform the like images into a tensor, because you already images that is in the in the pixel form, and that is basically the numpy, you can numpy array, but that particular pixel you have to convert into tensor. Okay, for that case you have to use the basically, for that case you have to use basically the transform. Again we will see the problem means we will do many deep learning projects, so don't worry for that. For this is the really basic project, this is the first project you can just say, and you should know only the basic concept. If you are really clear in this, then in the second project we will do the object detection or any image classification problem. In that case you will see more about this transformation and this thing. Okay, transformation means basically you are just transforming that particular image to a tensor. That's what you are going to use, because PyTorch accept tensor. Okay, so I don't think so you will have doubt in this. And here you can just, what you can just write here, transform, and then after that you have to just no need transform this one. Okay, and then after that you have to already you have just you have to just create transform, already you have just imported this thing to tensor. Okay, to tensor, this one. Okay, so I don't think so you have doubt in this. Then after that what you have to just write, download. Okay, download equal to true, that's it. The similar way you have to write for the test, for the test set you have to write the same thing as it is, you don't have to write any different things. Okay, what you can just write here, test.mnist, you can just create mnist data set, and then here you have to just write the same as it is, root where you want to download this test data. You have to train, you have to mention here false, because this is not your download for the training data set. Okay, but you have to transform. Okay, the transform, the way you are just writing is same. Okay, you have to just transform this image, what you can just write here, transforms dot to tensor. Okay, and then after that you can even pass the download equal to true, that's it. Okay, so yeah, this was the basically you already creating this downloaded. So what you can just run this particular, and hope so it will not give it, it is running, hope. And here you are just downloading the, it will start in the progress, because this particular data set it will take time, it's approx I think 700 or 800 MB. But yeah, it already has been downloaded in my system, so no need to download it again, because that particular path I already have just downloaded in that particular path. Okay, so if you are just doing the first time, then it will take some time, it will take 2 minutes to download this particular file. So you have downloaded it train set, you have downloaded it the test case. Okay, so now what you have to do, if you want to see the classes, the number of classes you want to see, what you can just do, you can just write here train set, you already done. Then after that what you can just write classes, that's it. Number of classes you are just seeing, see, you have total 10 classes starting from the 0 to 9. Okay, you have 10 classes, and each classes has the digit of 0 1 2 3 4. Okay, so I don't think so you have any problem in this. Even if you want to see the shape of this particular train set and test set, what you can just write, train train data set shape. Okay, you are just writing the shape of train, you can just write anything. So what you are just going to write here, train set, train underscore set, and then after that what you have to just write here, you have to write data, and from data you have to write the shape. Okay, this here is, and the similar you can just go for the test. Okay, you can just copy paste, that's it, it does not make you don't have to write again and again. So you are just going for the test set, and you can just write here test set. Okay, so what you can just do, you can just run this particular, and you will get the answer here. What you have, total 60,000 images, that is all, and each image has the dimension 28 cross 28, and you have test dimension is, test dataset has 10,000, and each image has dimension as 28 cross 28 pixels. It is really small. Okay, you can just say, and it is basically a one, means it is not a colorful image. If the channel is 1, then it's basically a grayscale image, and if your image channel is 3, then it's RGB, it is basically the colorful image. Okay, I think you know this thing is, this is really basics. Now the third thing, you have just downloaded the dataset, now we have to move in the another path. The basically the path is the train loader. What is the function of the train loader? So why we are going to use the train loader, and why it is the basic important concept in the, because the already I explained you about this train loader. Whenever you want to divide any data set into batches, you have to go for the train loader. Okay, so train loader, suppose you already have given example, suppose you have total 100 images, and you want to divide that particular data set into 10 batch. Okay, so each batch contains the 10 image, 10 image, 10 image. What we are going to use with the help of data loader means, you are just preparing your data set. That's it. Okay, so that this particular data train loader or test loader data set you can just directly give to the model during the training time. Okay, so we will see this thing. So what you can just write here, train loader, I'm just defining the variable name, and here already you have just imported this library train loader, and here it will you have to pass three parameter. Okay, the first parameter the train set. Okay, the train set, and the second parameter is the batch size, how much batch size you want to take. Here we are just taking for the example, we can just take any number of example like 64 we are just taking. Okay, and then after that shuffle, you have to say whether you want to shuffle this data set, and you can just pass for the training you have to pass the true. Okay, and for the testing it does not make any sense if you are passing true or either you are passing false. Okay, so data, because you are just adjusting the weights only during the training period, because the training data set is really more important as compared to the testing, because during the training period you are just adjusting the weight during the back propagation time. Okay, so that was the really easy concept what you have to write here, train set, then after you have to pass the batch. Okay, so batch size again you have to mention here, and you are just mention as a true, and shuffle you are just mention as a false. Okay, no, you can just write true and false, this does not make any sense, already I explained you about this. Okay, now we will check the train loader. Okay, so if you want to check the shape of the train loader, okay, what you can just do, you can even write the for loop. Okay, this is what I'm just writing, for image comma labels in train loader, you can just write this thing, train loader. Then after that what you can just do, you can just write print, basically print images dot shape. Okay, you can just write print images dot shape, and you will see the shape of that images, and I'm just going for the only one batches. Okay, so it train loader means basically how many total batch it has been divided. You have taken batch size as 64. Okay, so total batch size you have taken 64. Okay, so first 64 image it will go, and it will just go through, and how many time it will go to iteration you don't know. Okay, you have how many time it will go, 60,000 total you have data, training data divided by 64, that one will be your total number of batch. Okay, and this is the batch size, basically that you have in one batch you have 64 image. Okay, what you are going to see, so you will get 64 comma 1 comma 28 comma 28, it means that you have total 64 images in one batch. Okay, and you have channel number of channel is 1, and height and width of this particular image. Okay, so I don't think so you have doubt in this particular things, and it was really easy. The next thing what you can just do, even you can just see with the help of iterator. Okay, so we have to visualize this data set. Okay, the in this particular with the last one we are going to use to visualize this data. Okay, so how you are going to visualize this data, you can just write data iter, I can just do this one also. I think you know about the iter make the object so that it's like more memory efficient. So whenever you are just making the data iter and you are just writing iter iter, it makes the, it hold the memory, it make the object, so that whenever you are calling dot next, so it is just iterating one at a time, like the break, the first one you are just implementing the batch, that's it. Okay, so we'll see. Okay, don't be confused in this, you have to just pass the train later. So you are just seeing only for the train loader. Okay, so you can just pass this one, and then after if I'm just saying, so it will return the two things whenever you will do the data loader dot next. Okay, the one will be the images, total images and their labels, total 64 images and their 64 labels of that images. Okay, so what you can just write here, data iter, you can just write data iter, and then after you have to just call the next. Okay, so what you are just, whenever you are calling the next, okay, the first batch it will goes, and it will just give you the number of images and labels, it will be the same as it is. Okay, but here it's like you have to call that, and then after again if you do data iter dot next, it will give for the second batches. Okay, so you are just making the object of that, and that's it. And then after if you want to see, if you want to see this particular only the one image, if you want to see, then what you can just do, with the help of matplotlib you can just plot, you are just seeing only for that particular one, the first image, or in that particular you have total 64 images, you are just seeing the first images. Okay, that is the images one, and you are just converting that particular to a numpy, because it was a basically a tensor. But matplotlib, whenever you will give that particular tensor to the matplotlib input, then it will not give, it will give you an error. Okay, so you don't have to go for that, you have to convert for tensor again to the numpy. Okay, the how you can just do dot numpy, you can just mention to convert this thing, already we have seen in the part 1 video. Okay, and then after you have to remove this particular one dimension, you don't need to do, because you, whenever you are just plotting any images in this matplotlib, you have x dimension, you have y dimension, that's it. Okay, so what, with the help of skews, okay, you will able to remove this one dimension. Okay, so skews is basically what it is doing, it is just removing the one dimension, where it will find the one dimension, it will just remove that one. Okay, so that's what is the function of skews. And then after even you can just go for the C map, color map, and you are going for the gray. Okay, let's see. So this is the 5 again. If you are passing 1, then what you are just seeing 3. So this how you are just seeing the image. If you, and even if you want to pass in the form of batches, you can just pass, like if you want to see all thing in the one what you can just do, we can just do one thing more, like if you want to see all 20 images in one images, what you can just do that one also. So if first of all what you can just do, let's write figure plt dot figure, that's it. By default the figure size will be the 8 comma 12 comma 8 something. Okay, and then after that you have to just, I'm just saying, you have to just you are just doing this, visualizing this images one image at a time. If you want to see all 20 images at a time, you can just loop the, you use the concept of the looping. Okay, so that's it. If you want index, and then after that you want to do for in range of total, you want to do for particular 21. Okay, I'm just writing the random things, and then after that you want to do the subplot of that, because in the one plot only you want to see every images. Okay, plt dot subplot. Okay, so subplot, here you have to pass the total number of here you have to pass the 6 total number of uh, in that particular columns how many you want, and particular rows how many you want. Okay, even you can pass 2 rows and 20 column, that will be the enough. Okay, and then after you have to pass the index. Okay, so first image it will go and it will just print, it will just visualize, and second image, because in the one image, okay, you are just dividing into grid form, you are just making the subplot of that. Okay, so that is the concept of the matplotlib. So I think, I assume that you are clear with this particular matplotlib. Then after that what you have to just write, I am so, and then after the same thing you can just write here, just do the copy paste. Okay, so no need to do again and again. And but here what you have to just mention, you have to change one thing, that is the basically here you have to just write I. Okay, so that is the index. So just see what's the printing. If 20, you are just writing this what I was speaking about that. Okay, so you have total 20 images and you are just seeing this one. I hope so you understand this one. This was really easy concept, even because you are just seeing all the images into one image, you are just seeing into plots. Okay, in the one plot you are seeing the total 20 images. Okay, so this was the this particular video is only for the data, how you are just importing the data, how you are just training the data in the PyTorch, sorry, how you are just downloading the data in the PyTorch, how what is the use of data loader in the PyTorch, and how you are just visualizing this data. Okay, so this was the really easy concept. This was the part 2 video of this particular PyTorch. In the next video we are going to see how we are just creating the model, and creating the model is the really important concept you have to understand, and that we are going to use with the help of ANN. Okay, so that we are going to see in the part 3 video. Hope so. If you like this video, please subscribe our channel. Thank you. Part 3 of the PyTorch series. So in this particular video we will see how you will create a model, how you will create a ANN model, how you will build a neural network. Okay, so in the last previous 2 video we already have just work on the basics of the PyTorch, and also we have seen how we are just doing the data pre-processing step in the basically in the PyTorch, where you are using data loader. Okay, so now in this particular case, we are going to build an ANN network. How you can create a ANN network. Already in the previous class, you have seen how we have just visualized the data, how we have used the data loader concept, each and everything. I hope so you have gone through that particular part 2 of the video. So that is of the continuous of this particular part 2 video. In this, we will build a ANN network, and how we will build a ANN network, I will go step by step. Okay. So first of all what you have to do, you have to just make a class. This is the part of, you have to make a class that you can just give ANN or any of the name. Okay, and then particular you have to inherit from nn.module, that will be your parent class. This nn.module will be your parent class. Okay, that already has been, PyTorch has been defined. You don't have to define again about the linear, what is linear, how you are going to use that one. Okay, then after that you have to make a constructor for this particular ANN. How you are just making the constructor, and you are just passing self and there, that's it. Okay, so after that you already make the constructor. Now you have to call this, you have to initialize the constructor of this particular NN module. Okay, it's basically, I'm saying you have to initialize the dot init function of init method of the parent class. Okay, for that you are going to use the super. Okay, so super is basically, it's create the virtual object of the parent class. Okay, so from the super you want to initialize basically this parent class. Okay, the parent class of the init method. Okay, so you can just write init. Okay, so I think you are clear with that. Okay, so you have, it's like really basic. You have just made the an class, and you have and this is your child class, and you have inherit from your parent class, that is your nn dot module. Okay, so already there are many things that already has been initialized. You don't have to initialize again and again. Then after, you are just creating the one constructor, that is basically init method. Okay, so in that you are just defining super. Okay, super, you are just creating the virtual object of the this particular parent class. So basically you are just calling the init method of the parent class. You are just initializing the init method of the parent class. Okay, so now after that, you have to make one more particular first fully connected layer. We are jumping to the first fully connected layer. Then after, how we will going to make that one? So you have to just write, this is the first fully connected layer, means how many hidden layer we are going to use. In this case, we are going to use three hidden layer. Okay, so three hidden layer means you have four fully connected layer. One will be your input layer, and the rest three will be your hidden layer, and then after that it will be your output layer. Okay, so here you have to only initialize that particular model, how many neurons you want to keep in that particular model. Okay, so for that, what you are going to use, nn dot linear. So nn dot linear is basically, you have to pass the parameter as how you have to pass the parameter. The first, it is the input feature, and what will be the input feature of the first fully connected layer? It will be the image size, that is the number of feature, and here it will be number of feature. It is basically your pixel size. Here the pixel size is what? So in the input layer, how many neurons you want to keep, that's depend upon your dimension of the image. If your dimension of the image is 28 cross 28 cross 1, so that is the grayscale, then 28 cross 28 cross 1 will, that number of multiplication will be the neurons in the input layer. Okay, so for that, this is the input layer. You are just creating the number of neurons in the input layer, and then after, you are just passing through the first hidden layer, that will be your output for the input layer. Okay, in that case, if you are using, I am just using 256. Okay, so this is the first hidden layer. You are just passing 256 total number of neurons in the first hidden layer. Okay, then after that, what you have to just pass, you are just getting, and again the second fully connected layer, and you are just writing the same as it is. Okay, and here you will be, what will be the previous output, that for fully connected layer it will be the input. Okay, so previous output was total number of neurons was 256, so you have to pass 256, and then after that, how many neurons you want to part into, again the second hidden layer. Okay, so I'm just using 128. Okay, so this how you are making the model complex, so that you are making a model too much heavy. It can easily handle thousands of data set or lakhs of data sets. Okay, then after, you are just making the fully connected layer 3, and you are just writing the same, and here you have to pass basically 120, the what will be the previous output, and for this it will be the input. Then you are just passing 128, and again we already have just discussed that we are going to use three hidden layer. Okay, so I think it's like clear for you, and this is your last step, last fully connected layer. Okay, so for that, again you have to just write the same as it is. Okay, and then after, you have to pass the 64 comma number of class. You are already have seen 0 to 9, we have total number of digits. So how many digit, how many target, or how many level of that particular data set, that will be the number of neurons in the output layer. Okay, so you have total 10 classes, then 10 number of neurons will be present in the output layer. So I don't think so. You have initialized your model. Okay, you have initialized your model, you have make your model, but till now you have not passed the data in this particular model. Okay, for that, you have to create one more method, that is a forward method, that is a forward propagation you are going to use. Okay, so basically, you already have built this particular data, you have just initialized the data. Okay, for then after that, you have just create one more method that basically use forward method. Okay, so forward method is going to what, it's like a forward propagation you are going to use, and that particular, you are just passing the image to the model, and then after, you are getting some results. Okay, so again, you are going to use self comma, and you are just passing image. Okay, I'm just writing image. Okay, so first of all, what you have to do, you have to just resave this particular image, because this image is, whenever you will see the image dimension, like whenever you will see, because in data loader you are going to see the dimension of the image is 28 cross 28 cross 1. Okay, that is the channel is 1, and you have total number of image in one batches, it is a 64 total number of images. Okay, so what you are going to use for that, So for that we have to use here, you have to resize that particular, because in the input layer that number of neurons you are passing, that is 28 cross 28, means you have to flatten that particular image, means 28 cross 28, that is the that is the shape. Now you have rows, you have width, you have to convert the 2D image to basically into 1D image, okay, so that that number of pixels will be passed to the input layer. So I don't think so you have doubt in this. Even if you want to read more about the how many neurons you want to pass in these particular layers, already I have made one video, that is the input layer, hidden layer and output layer, how many neurons you have to pass. You can just, I will just give you the link in the description, you can directly watch that video. That was really easy. And then after that, what, suppose here what you have to do, image, in that already we have seen view is basically used for the resizing in this particular PyTorch, okay. And here you are just passing -1. We already have gone this string in the part 1. If you have not watched in the part 1 of the PyTorch, you can just go through and watch this one. I will explain this thing in really deep. And here you are just resizing this thing into 28 cross 28, okay. And you 28 cross 28, and you are not passing into 1, basically you can just pass. But if you have the 3 channel, you can just pass into 3, okay. So you are just resizing your image into 1 dimension, you are just flattening your image, okay, so that that number of pixels should be passed in the input layer, because input layer is basically the total number of 28 cross 28. I don't know what the multiplication, it may be like 764 something. So that number of neurons, it is present in the input layer, and then that's why you are just multiplying with every pixel, so that you are getting 2 dimension into 1 dimension, okay. That's why you are just reshaping this particular thing, okay. Then after that you will pass, then after you have reshaped this particular image, then you will pass to the first input layer, okay, the first fully connected layer, okay. How you will just pass, just write first fully connected layer, and here you have to pass basically the out, okay. This is what you already have done, this is the complete. Then after that you are going to use the activation function, okay. So activation function is really important concept in this particular. So for that, what you have to just initialize the activation function, and you are just present in at re, you have to just pass in the ReLU activation, okay. So I don't think so you have doubt in this, you are just initializing the ReLU, okay. So you are just initializing the ReLU from nn.ReLU, somewhere you will find f.ReLU, okay. So either you can go for ReLU, it is present in the neural network also, RNN module also, and it is present on the functional also, okay. You can just import that particular functional also. But the thing is, the difference between them will be basically in the functional you have to pass, you don't have to initialize, and here you have to initialize whenever you are going to import in the from nn.module. So it's up to you how you are just going. If for the beginner, I recommend that you should use nn.ReLU, first initialize this, then after you are going to use this one, okay. Then what you are going to use, you already have this particular image you have done, and then after you have just passed this image to the first fully connected layer. Then after on that on the top of that you are going to use the ReLU activation function, okay. So for already you have initialized this self.ReLU. So what will be the previous output, okay, you are just going to override that one, okay. What will be the previous output, that will be the input for the this, okay. So you are just using ReLU, and you are just passing this basically out, okay. So I don't think so you have doubt in this. Then again you have to do the same as it is, okay. You have to just it, why out of time just writing, it is just overwriting the what was the previous, okay. That is not a big issue, you already know if you are in the deep learning. So then after that fc2, then again you just pass out to what will be the previous output, it will goes to input to this particular second fully connected layer, okay. Then after that you are going to use again the ReLU activation function, okay, self.ReLU, and again you have to pass this basically out, okay. Then again you have to make another fully connected layer, self.fc3, and here you have to pass out, okay, the same method. Then after that again you have to use a ReLU activation function, ReLU, and again you have to pass the out, okay. Then again you have to just mention out equal to, I don't think so you will have any doubt in this. And for this is your last fully connected layer, and then after again you are just passing out, okay. But what after that, what we are going to use after that, we can use after that softmax activation function, okay. Because you have just passes everything ReLU basically used in the hidden layer. And even for the activation function also, I have just uploaded the video which particular activation function you are going to use in which particular layer, in input layer or hidden layer or in the output layer. you have to be more conform with that particular thing, because activation function is also playing a major role. Okay, so what you are going to use here, ReLU activation function we are always using in the hidden layer, but for the output layer you have to use some activation function, so you will able to see which output neuron you are getting the higher total number of value, and that particular neuron you should say that model has been predicted. Suppose out of 10 neurons, so out of 10 neurons you are saying that second neuron is getting the highest value as compared to the all the 10, all the 9. Okay, so what that particular neuron will be the output for that, because you are getting more weightage, more higher calculation in that. Okay, so this is the really basic, you already know about this, and you are completed about the ANN network, how you are just building the ANN network. Then for that what you are going to use, then after you are going to return this out. After you can see, again I will just guide you why we are not using softmax whenever you are using cross entropy loss. Okay, so the thing is that whenever you are using cross entropy loss, you are not going to use softmax activation function in the output layer, means after that you are not going to apply, because whenever you are using cross entropy loss, by default they will use first activation function, that is the software activation function, then they will calculate the loss. They have the process of that, because you no need to again you have to initialize the software again function, again they will use software activation function, so that will be like useless. If you are going to use, just keep in mind, if you are using a cross entropy loss in the PyTorch, then you don't have to write the software activation function on the output layer. Okay, by default software activation function is implemented in the cross entropy loss. If you are, if that particular you are not using that particular loss, if you are using mean square loss, then you have to write the software activation function. You can just do the same as it. Okay, you can just write the same soft max, and you have to just write the same as it is. Okay, so it will basically this soft max I am just talking about, and you have to just pass this one, and the same as it is output equal to self dot soft max. Okay, and here you have to pass the out. Okay, this will be your output, that's it. This was the model you already created, and I don't think so you have doubt in this. Okay, so softmax basically why we are going to use, because you are just converting every what in, because in the output layer you have total 10 number of neurons, 1 2 3 4 5 6 7 8 9 10. Okay, in 10 neurons you will get some amount, in some value you will get in the all the 10 neurons, and which particular neuron you will get the higher value, you will say that particular neuron is the our output, the model has been predicted. That is the softmax, they are just converting out of 10 into a probability form. Okay, so means the higher the probability of the that particular neuron, you are saying that that is our output that has been predicted by the model. That is the use of the softmax, it is only converting that your discrete value into a probability form. Okay, so I don't think so you have doubt in this, and this was the in about the how you have to create the ANN model, how to use the constructor of that, and how to build a forward method, and then after you can just make the object of this, have to just write ANN, that's it. Okay, or toss.nn, I have done some mistake, yeah, this sorry, oh, sorry for that, I have written small l in place of the capital L. Okay, so your model has been, see you already created the object of that, you can just print this model. Okay, you want to see how model looks, you can just do the same, see 784. Okay, so 784 input feature, and this is your output feature. Okay, the bias we are just taking as true. Okay, then after again this is your first second fully connected layer, this is your third fully connected layer, and this is your fourth fully connected layer. Okay, so this was the basic, and then after that you are going to use softmax activation function, but in the case when you will use, whenever you are not using cross entropy loss. Okay, so mainly 99% you are going to use cross entropy loss. Okay, in this particular deep learning you will not use the mean square error. Okay, so that's why you can't compare with the discrete value, that is 0 1 2 3, they are in the label. Okay, for that what you are going to use, you want to use cross entropy loss. So whenever you are going to use cross entropy loss, you no need to use this particular, okay, this last line you don't need to use. Okay, and if you are not using that particular loss function, then you have to pass this thing. Okay, so there, that was the basic concept how to create your ANN model. In the second video we are going to see how you are going to use, how you are going to create a CNN model. Okay, so that you will be more you will be more practical in this field, because PyTorch is not a really big complicated deep learning library, so it's like really easy how to create a model, simple model. In the second we will see how to create a CNN model. Okay, so that will be our next video. So hope so, if you like our video, please subscribe my channel. Thank you. Part 4 series of the PyTorch. So in the last 3 video the part 1, part 2, part 3, we have seen how we have done the basic concept related to the PyTorch. We have seen the how we have to deal with the data loader, and in the part 3 we have seen how you have to create the model using ANN, a neural network. Okay, so you are using a PyTorch deep learning library and you are just creating ANN model. But if I in this particular video we will just look up for the CNN, that is a convolution neural network. Okay, basically you will create a model that the already you have just created ANN model. I can just show that what we have done in the previous video, and this particle for this video we will create a CNN model, that is a convolution neural network. Okay, so the theory part, if you really don't know about the CNN, then please, I will just provide the link in my video description. From there you can even see or even go to the my website where I have written about the CNN. Okay, so here you have to focus on that things, what are CNN, how to create a CNN model using PyTorch. That will be our basic agenda of this particular video. Okay, so how we have to just create a CNN, I'll explain you each and every step. Okay, so basically the first of all you have to just define the class, that is a CNN, and here you have to inherit from the same as it is what you have done in the ANN. That is your parent class will be the module class. Okay, NN dot module, you can just inherit from there. Okay, then after that this is basically CN is your child class and NN dot module is your parent class. Okay, then after you are just defining the constructor for that. Okay, that is the init method for that. Okay, you are just passing self, that's it. And then after you will use the super to initialize your parent class. Okay, parent class init method or constructor of your parent class. So you, with the help of super, you can already, this thing already I have explained in the previous video. Okay, so what you can just write here, cn comma self, and then just initialize this one, init. Okay, so I don't think so you have doubt till now in this. Now it's come to know how we are building a convolution neural network. Okay, so already you know that why we are using CNN whenever we have ANN. So CNN is when we are dealing with the images and videos data set. At that time CNN is giving you more accuracy as compared to the ANN, because in CNN you are only focusing on the important area, that is the most important, that particular in an image, you can just say in image in particular area where the object or the, you can just say anything, it is present, object is present, you will, that particular CNN model will focus on that particular area rather than it will focus on all the images area, you can just say. Okay, so what I'm saying, suppose you have an image and in that particular, in the side portion you have the image of a person. Okay, so your model, you want to build a model that can able to detect the person. But whenever you are dealing with the ANN, what it is doing, it is generally converting ANN to a particular, it is just converting into number of pixel, that what you are just going to use. But in the CNN it is really different. Okay, so in CNN you are extracting only the person area, where the person is, you are just focused on that particular area. That's why. And then after, why this important one, why we are using CNN, already I've said you about this. And that's why you are reducing the number of parameter when as compared to the ANN. In ANN was basically, and if you are just going for the input layer, so in ANN what you are going to use, you are just defining suppose you have the pixel size, already we have seen. Okay, so 784, this is your pixel size, that will be the number of neurons present in the input layer, that we are dealing with a small dimension, that is really 28 cross 28. But even in the real world, even if you are going to use 250 cross 250 cross 3, okay, that is the dimension of the image. Okay, so that number of neurons, multiplication of neuron will be present in the input layer, so that you are making your model too much complicated model. Okay, and the second demerit of the ANN, as whenever you are dealing with the computer vision, that is the images and videos, so there are the pixel, they will be the independent with each other. Okay, so you will not focus on that particular area where the person it is. But in the CNN, what you are just doing, you will focus on the image, and in the image where the person is, suppose I have given example of person, so where the person in that particular area, the image will focus, the rest it will be like useless pixel. Okay, that you are just doing, that useless pixel you are removing in the CNN. Okay, that is the plus point in the main difference between the ANN and CNN, what you can just do. Okay, Now already I've just said you about the thing. This is the theory part, even I explain you now also. So before starting the coding part, even you will get the more ideas. Okay, so now the rest, the second thing, that what you are going to use, you are just creating the first convolution neural network. That is the first convolution you are just tracking. Okay, then how you will just write from nn dot conv 2d. Okay, you have to just call the conv 2d, this one, and it takes 3 to 4 to 5 parameter. You can just say it takes the input feature, like in the input channel, it take the output channel, it take the kernel size, it take the padding. Okay, and it take the strides. Okay, so what we are going to use, first of all, input channel. Okay, so what a input channel will be, basically one, because whenever you are just, already we have seen this, the image we are dealing with, this is basically 28 cross 28 cross 1. Okay, basically it is a grayscale image. That channel of that particular image is 1. You have to give it there. Okay, and if your image was a colorful image, then you have to give in place of input channel as 3. Okay, either your channels will be 1 or 3. Okay, then after you are just defining the output channel. What is output channel? Output channel is, you are defining the number of filter you are going to use in the CNN network. Okay, so number of filter you are going for the first convolution layer you are just creating. In that particular, how many number of filter you are going to use, either you and but that particular filter you don't have to choose. You have to just define how many filter you are going to use. That and which filter it is going to use, that will be decided by themselves during the training period. Okay, whether they will just select the edge detection filter or line detection filter. There are many sorts of filter it is there. Okay, so here you have to define number of filter you are going to use for this particular CNN network. Suppose we are going to use for this particular CNN network like 16, I can just take. Okay, and then the third parameter you have to pass, if the number of channel you have already, the number of filter you have already provided, but each filter size, what will be the filter size of that particular, or what will be the, basically the kernel size of that. Okay, so basically it is called as a kernel, number of kernel, or the filter you can just say. Okay, and here you have to pass the kernel size. Kernel size means each filter, what is the size of each filter. We are going to use 3, means 3 cross 3, that is the size of the each filter, and you have total 16 filter. Okay, that what you are going to use for the first convolution layer. Okay, it's clear? I don't think so you will have doubt in this. Again, we are just creating another convolution layer. You can just say convolution 2 layer, and here you are just passing nn dot conv 2d. Okay, the similar here you have to pass, and here how much in your, how many input channel and output channel it will be there. So input channel will be there, what was the previous output channel. Okay, so here you have to pass input channel. Again, I will go with the mathematics, explain how you have to choose the each by each layer, how, what will be the dimension of the image. Okay, it is really important things. Okay, you have to decide how many you want to keep the neurons in that particular, means how many filter you want to take in this particular. Then after, you are going to use ANN as a hidden layer in the CNN. Okay, this is the important concept. So input, let's focus in this part, convolution 2. So here what will be the input channel? Input channel will be the previous output. Okay, the 16. Then again you have to define the output channel. Okay, the output channel will be basically what it will be. You can just say by 30, I am just defining 32, and again you have to say kernel size. Okay, so kernel size again is basically will take 3. Okay, so again you will say we have not defined stride, we have not defined padding, so we no need to do in this particular problem. This is the really basic thing. You should understand how to create a CNN network. By default, stride are basically, you can just stride at 1 and padding is 0. By default they have a value. Okay, even you can just change this one in the later real world problem. Again we will see, because we will do many applications related to the PyTorch for creating using CNN. We will use many pretend model. At that case you will see. Okay, so you have created, we will only use the 2 convolution layer. Okay, so you have created the 2 convolution layer. Okay, then again you have to define the max pooling also. You are just initializing the layer, that's it. But after that we will create a one more method. Already I have said you the forward method, that is doing the forward propagation. In that, how the flow of that particular image will go, at that time we will see. Okay, so you are just initializing the network, that's it. Okay, so here what you will just write, you are just creating, you are just initializing the max pooling. Okay, so what you can just write nn dot max pool, and here also you are just going for the 2D, and here you have to define the size. Okay, you are using 2 cross 2 total filter size of this particular max pooling. Means if you have dimension of 4 cross 4 image, and if you are using max pooling as 2 cross 2, then it will just give the dimension as 2 cross 2. That's it. Okay, like I am supposed to using like 6 cross 6, our size is image of size is, it is okay. And if you are using max pooling on top of that, then your dimension of image will be 3 cross 3. Okay, it is not reducing the depth, it is only reducing your size of the images. Okay, okay, max pooling, that is the function of the max pooling. Then after that you have to initialize also the activation function, what you are going to use in this particular layer. Okay, so here you have to just write nn.relu. Okay, so you have to write this particular nn.relu. So I don't think so you have dot in this relu. Basically you have to write capital U. Okay, so you are just writing the capital U, and then after again now you have just created the convolution layer. You have means you have just initialized the convolution layer 1 2 convolution layer, you have done the pooling, and then now you have initialized the relu. But you have to do one thing more, that is you already have said you the fully connected layer, that is the ANN you will use in the CNN as a hidden layer. Okay, so what you are going to write, you are just creating and again the fully connected layer. Okay, so after the extracting the most important feature from that particular image, you will just pass that whole to the ANN so that model will train. Okay, so for that what you are going to use, you are just creating a linear, you can just write linear, and here you have to pass this particular you have to pass what you have to pass here. Now it will be like what will be the input and what will be the output. Output will be basically we will use only the one fully connected layer. Let's stick to the only one fully connected layer. But here you have to see what will be the input here. Okay, so what will be the input? For that we will just again we will just do some mathematics part, so it will be like easy for you. So because you know that output will be the basically 10, that is the number of class, but how many neurons you want to keep in the input layer? It was like previous, it was really easy, you are just multiplying the number of image 28 cross 28 into number of channel, you are doing that thing. Okay, but now if I am just explaining the same thing, but what will be the number of neurons in the input layer, what you will write for that? Okay, for that you have to create one forward method. Okay, I'm just creating forward method, then after I will just say what you have to write this thing. Okay, forward, don't be confused now, so I'm just explaining you the basics. Okay, so you will not need anywhere to go and you can just learn directly from here and here. Then after that what you are going to use, the first network you will just image you will pass to basically your convolution neural network. Okay, they accept 40, they accept 40 means I'm just saying they accept the batch size into number of channel into height into width, they accept this shape. But in previous you have to resize this thing that you have done in the ANN, but here you don't have to resize this thing because they accept this particular basically the what you have dimension of number of in batch size, number of channel, height and width. Okay, then after the first after completion of the CNN, whenever you will use ANN as a hidden layer, at that time you will do flatten. Okay, that you will convert every 2D into 1D, what you are going to convert. So what you are going to do, the first layer what you will just write here, you will pass this particular image to the particular first. Okay, so what you are going to write, you will call this particular self dot convolution, one operation you have done, and you will pass this image. Okay, you have just passed this image. So what will be the output of this? Okay, so what will be the output of this, because what you are going to use, see what you are going to use here. First I will say you the brief formula. Okay, so anywhere you will see this thing, this is the really the basic formula for that, n minus f plus 2p by s. Okay, this is the plus 1. Okay, this is the basic formula, or you can just say shortcut formula. Okay, so calculating the number of output what you will get in the after convolution operation 1, after max pooling, after again convolution layer 2, again after max pooling, what will be your output, so that you can decide how many neurons you want to keep in the input layer. Okay, that thing you have to be considered in this part. So what you are going to use for that, for the first operation what will be the output. So during the convolution 1 operation you will say that n is basically the dimension of image, that is a 28 cross 28. Okay, so we will just write 28 minus f is basically your the kernel size. Okay, the kernel size is your kernel size. Okay, the f is basically your kernel size, is kernel size is 3. Okay, padding already I have said we have not defined, so by default padding is 0, so into 0 divide by strides by default is 1. Okay, and whole plus 1. Okay, what you are going to use this one. Okay, so what 28 minus 3 is 25, 25 2 into 0 is 0, to 25 plus 1 you are getting 26. Okay, so this is your output after performing one convolution operation. Okay, the first convolution operation, and in this case, what will be the depth of that? Depth will be the output channel number of filter. So 16 will be the depth. Okay, basically means this is your dimension of the images, and this is the depth. Okay, previous it was 1, but now you are using 16 filter. Okay, so you have 26 into 26 images, and you have 16 times 16 filter you are going to use. Okay, then after that, what you are going to see, you will use the ReLU activation function. Okay, that is really easy. You have this inside, just pass this particular out. Okay, then after that, what you are going to use, you will use max pooling layer. Max pooling means you will just reduce the dimension of image, but you will not reduce the number of channel. It is not reduced in the max pooling, only the dimension of image you are going to reduce. Okay, so what you just write here, self dot, you are just writing self dot, and here you are passing basically pool. Okay, the pool you are just passing, that is the max pooling we have defined, and you are just passing the what was the previous. Okay, so what will be the output for that? It's basically divide by 2, basically because you have just taken the size of that particular kernel size of that particular max pooling, you have taken as 2. That's it. Okay, filter size you can just say, so 2. So basically you are just dividing the whole images by 2, but the number of channel will not divide. Okay, so 28 cross 28 was the previous output of after performing the first convolution layer, and in the ReLU you are just you are not doing, you are just making your network a nonlinear model. Okay, and you are just taking that particular neuron which has the more you can just say the pixel, and if the negative pixel it is there, you are just removing that pixel. Okay, because that pixel does not contain any information what you have done in the ReLU. Then after you are just performing the max pooling. So max pooling means you are just reducing the dimension of image, that's it. Okay, but you are not reducing the depth of image in this. Okay, so it will, the size of this will be 13 cross 13 into 6 means divided by the 2, this will be, because you have taken the 2. Okay, 2 filter size. This is the first you have just gone for the convolution layer, ReLU layer, pooling layer. Again you will do the same as it is. Okay, then again you will do the same as it is. You will just write the convolution 2. Okay, you will just write this convolution 2, and again you will pass the output. Again, what will be the after what will be the output for this? Okay, so you must have to know this one. What will be the output? Again you will use this formula, 2n minus f plus 2p by s plus 1. So already you know that previous this will be your output. Now this was the output, then you will use 13 cross 13 cross 16. So this is the number of size of the image minus your filter size. Again you have used the kernel size as a 3. Okay, plus 2p means you already have the 0 padding, divided by s. Okay, so plus 1. Okay, this is what you are just getting. So what will be the output? 13 minus 3 you are getting as 10. 10 plus 1 11, 11 cross 11 cross, and here number of output will be the number of channel, means number of depth will be the number of output channel, that will be the 32. Okay, so this is the output after performing the second convolution layer. Okay, second convolution layer. Then again you have to pass for the ReLU. Okay, self dot ReLU equal to out, you are just writing, and again you have to pass out equal to self dot, I think so they are really easy, self dot pool. Okay, again you have to pass out. Okay, so this already you have done, and in that again what will be the output for this? Okay, you are just dividing this thing by 2. Okay, that's what you are going to use. So what will be the output? 5 cross 5, you are just dividing 5 cross 5, means roughly we can just take 5 cross 5, and on basically you are not reducing, you are not reducing the basically the dimension of the image. Okay, so like into, you can just say 32, this will be the okay dimension. What I'm saying, you are just reducing the dimension of image, sorry for that, you are just reducing the dimension of image, but you are not reducing the depth of the image. Depth of the image will be the same during the max pooling layer. Okay, that is the convolution layer. Okay, so this was the basic concept of this particular forward propagation. Then now you will say what we have to write here. Okay, so here what you will just write here, you will write here 5 into 5 into 32, that will be the basically the ANN network. Now means this, after the performing of this, you will just use the fully connected layer. Okay, again wait, I will just jump to the main thing. Okay, so after that what you will do, you will resize it. Okay, so resize so that you have this thing in the 28 cross 28 cross 1, that all thing you have to do the flatten means you are just changing that dimension to a 1D dimension. Okay, so that you can just fit to the ANN network. Till now you have just performing convolution layer, ReLU layer, max pooling layer you have done, but the last thing you have to do again, that is the ANN, that is the fully connected layer you have to pass. Okay, so you have to do the again you have to resize what you have done here. Okay, so now you are using the same, now you have to do this thing, you have to resize this particular thing into this. Okay, so how you are going to resize? Out equal to, you will just write out dot view with the help of view, and here you are going to write here -1, and then after that it will be like 5 cross 5 into 32. Okay, because output dimension of now image gone to 5 cross 5 into 32, and previous in the ANN what you are going to see 28 cross 28 into 1. So you are just seeing how much you have reduced your dimension of image. Okay, so I don't think so you have doubt in this. See, the number of pixel is reduced, and even you are getting the most important feature, means the in which part the person is or the object is, you are getting that particular pixel. Okay, so this is what you are doing. This particular 5 cross 5 cross 32 you have to pass here. That what I was speaking. So if you know this one, this will be really easy. Okay, okay, so 5 sorry for that, 5 cross 5 into 32 you have done this one. Then after that what you are going to use, you are just you have to use the basically the, you have to pass this thing into fully connected layer what you have created here. Okay, so you have to write this self dot fully connected layer 1, and you have to pass the out. Okay, this is what we have to pass here. So what you have to pass here out, and then after that, that's it. So you already have passed this previous input, what was the previous input, and you have passed here, and then after this will be your output. If you are using the cross entropy loss, no need to pass after that activation function, that is a softmax activation function. But if we are using some other loss function, then you have, again you have to just throw the activation function. That is how we have done this one, self dot softmax out. I think you understand much better in the ANN also, so no need to explain again about the softmax activation function what you are doing in that. So yeah, this was the how you are just creating the model. Because we are going to use for the loss, we are not we have to just return this out, because we don't want software activation function, because by default we will use cross entropy loss. So by default they have the software activation function. First they will implement the software activation function, then after they will calculate the loss. Okay, this thing what they are going to use. So no need to use this thing, and you have created your model. Now you can just initialize your model. That's it, you are just initializing the model. And this what you are going to see, and see the parameter. So print model. Okay, see this how the model looks. This is what I was expecting. Okay, so you are just getting everything: convolution layer 1, convolution 2, max pooling, fully connected layer. Okay, so this all about was the convolution layer, how to create a CNN model using PyTorch. Okay, I think so you don't have any doubt. I explain you about the each and every step. I explain about the formula also, how to create. In the next video again we will go through the how to use RNN. Okay, so RNN, we will create RNN model. Okay, so we will able to see in the using the PyTorch. So you will, and you will use the same MNIST data for that. Okay, so that's it for the this video. So hope so if you like our video, please subscribe our channel. Thank you. Back to our channel, that is AI next generation. In this particular video we will see how to create a RNN model, as we have done the previous, that is we have done the CNN model, how to build the CNN model, how to build the ANN model. Okay, and rest what is the basics of the PyTorch and data in the PyTorch data loader. Okay, so we have gone through this particular concept. Now we will just make another model, that is a RNN model. Okay, so you already have built the ANN model, you already built the CNN model. Now this time we will build the RNN model. Okay, that is a recurrent neural network. Okay, but the thing is that whenever you are dealing with the images of the data, at that time RNN you are not going to use, because it will not give you that much accuracy what the CNN it is giving. Even we will see this thing in the training time. Whenever we will train this data, that is we have just taken the MNIST data set, then you are able to see which particular model is giving a good accuracy. Because for the CNN, if you are just dealing with the images data, videos data, then directly go for the CNN, convolution neural network. Okay, so that will give you a higher accuracy as compared to the ANN and even the RNN. Okay, so now the thing is that you have to know how to build a RNN model. Okay, if you are just using this thing for the sequence of the text, okay, or sequence of the data, that is a text file, then at that case you have to use recurrent neural network. Okay, an advanced version is like a long short term memory, that is a LSTM. Okay, so I don't think so you have doubt what I'm going to start today. So for that you just build the class RNN. So if already you have gone through the ANN model, how to build the ANN model, how to build the CNN model in the previous video, so you will able to understand each and everything what we are going through the step by step, and it is not really complicated. You have to only give the hidden state and cell state, memory state, because in this RNN there is they only use the memory state, means what previous they have just learned from this previous data, they are just predicting the future. Okay, that is happening in this RNN. So they are just taking the sequence of the data. So I will just go step by step so you will able to understand. So first of all, you are just creating the RNN model. Okay, so in that you are just inheriting this module. Okay, so we are just inheriting this module. Then after the similarly you are just defining the constructor, that is init method of the RNN, and here you are just passing the self. I am just doing the hard code of this. Okay, so whenever for that, then after that what you have to do, you have to initialize this particular parent class, parent init or parent constructor. This is the nn dot module. Okay, for that you can use the super. Okay, so super, you have to just pass rnn comma self, and you have to just initialize the init method of the parent class. Okay, so you already have done this thing already. I have explained in the previous video much detail. Okay, so now it's clear. Now we will start to build the model of the related to the LSTM or RNN. Okay, the first we will take on at the LSTM, that is the more advanced version of the RNN, because you know that in LSTM you have three gates. You have input gates, you have output gate, you have forget gate. Okay, so they are in the theoretical part. You can just, even I will just give you the link in my description video, so you will able to go and read there about the theoretical part. I'm just this video I'm just concentrate in this particular how to build this particular RNN model. Okay, so yeah, we can just start with that. So the first thing, already you know that LSTM, long short term memory, they have the memory cell. So memory cell in the LSTM, it is really important since that was not present in basically in the RNN section. Okay, so that's why the advanced version of RNN is the LSTM, where in the RNN you are getting some sort of vanishing gradient problem. It was there. So to overcome of that vanishing gradient problem, means you are not updating the weights. Means whenever you have 200 or 300 words, you are going back to predict the future word. Okay, at that case memory power of RNN was really low as compared to the LSTM. So LSTM, they develop a cell state. Okay, so that holds the memory. Okay, what they have, the model has learned the previous or important was they are just holding in that particular memory cell. Even for that video I will just explain you the more detail of the LSTM, how it is working step by step. Okay, just concentrate for now how to build a particular LSTM model. Okay, so what you can just do, you can just write RNN. Okay, self.rnn, and then after that what you can just do, the first thing you have to just keep in mind that whenever you are just creating this particular hidden layer, or how many layers you want to give in this particular LSTM, you have to define here. Okay, so first of all you can just do what thing, you can just do one thing. You can have to just define how many hidden state, how many cell state you want to take. Even you can just do this thing in the cell, you can just define this thing in the constructor by default. Okay, it's up to you. If I am just saying that I want input, this is what I was saying, input, if I want input size, this is the input size. So in this input size will be what, so explain me what will be the input size for this particular. So you have to give the input size as 28. Why? Because you already know that Amnish data set has the dimension of 28 cross 28 cross 1. Okay, so you have width is 28 and the height is 28 and the number of channel is 1. Okay, so what does it mean? So 28, the first 28 pixel will go to the first, then after 28, then second, then 28 third. This step of this will be go, because 28 you have features, and the sequence of that particular one image is 28, means you have 28. Okay, 28 you have 28 you have rows. Okay, 28 you have rows, and 28 you have columns in that. So 28 row, one row it will go, and then sequence of that will be the total 28. Okay, so you have to give the input size as 28. Then after you have 28, then after that you have to define this particular hidden size, how much hidden size you want. So what will be the hidden size for that? So hidden size you have to define here. You can just mention here how many you can just give. Already we have seen in the hidden size, we are using the ANN model, that is we have kept I think 256. Even you can just start with the 256, so you can just mention as 256. And then after that what you can just do, then after that you have to define the number of layers, how many layers you want to kept in this particular model. Number of layer means how many LSTM layer you want to keep. That is basically one LSTM layer or two LSTM layer. They will stack one upon another. So you have to define one more layer, that is the number of layer you have to define here. So number of layers will be, sorry for that, number of layers will be here. I'm just using two. Okay, so you can't use more than two or three. You can use any number of layer, but it's depend upon your data set. If your data set is huge, you can use number of layer as three or four. But whenever you're dealing with short amount of data set, at that time if you are using number of layer as one, so number of layer as two and three also, then at that time it will give you the problem of overfitting problem or underfitting problem. That's depend upon your data set. So number of layer is up to you, how many layers you want to keep. Okay, but you have to see how many your data set is really huge or it is really light data set. Okay, so you have already have defined this thing. Then after that what you have to do, you have to define the thing is that you have to define the number of classes. Okay, so number of classes is how many classes we have. So you already know, I think number of classes is basically, I'm just taking all thing as a by default value. Okay, so you no need to again, whenever you will make the object of this particular RNN, no need to pass again this thing. And even if you want to change, you can just do this thing. But number of classes depend upon your targets. You already have 0 to 9 digit, means number of classes will be 10. Okay, so I don't think so you have problem in that. Just initialize everything first. So we can just do one thing first. You can just initialize this hidden, the first one, which is the input size. Okay, so which one we want? So hidden size we want in the for further use. Okay, so you can just define hidden size equal to hidden size, because we want this thing in the particular fully connected layer. Okay, then and even whenever you will use the forward method, at that time you will use this particular hidden state. So that's why we are just initializing this hidden state. So we are going to use in the forward method also, but the input side we are going to use here, so you no need to initialize that one. So even then after the number of layer, we are going to see how many layers we want to keep. Okay, so you can just define here, and number of layer you can just say. Okay, so it's fine. So number of layer you already have defined. Now you are just creating the LSTM layer, that is the RNN model you are just creating. Okay, so just define self.lstm or self.lstm, you can just create, and then after that you have to keep that from nn.lstm. Okay, lstm, you have to write this thing. Okay, and then after that you have to pass the input size, the hidden size. What is the input size? You have just passed that one, that is the input size. You don't have to write here. And then after that you have to pass the hidden size. Okay, so hidden size, and then after you have to pass the number of layers you are going to use. Already we have defined this thing. And then after you have to define one more thing, that is a batch size. So batch first, sorry for that, batch first. What do you mean by the batch first? So whenever you are just specifying that batch first is equal to true, first I will just write batch first equal to true. Okay, what you are just writing this one. Okay, you are just writing batch first equal to true. What does it mean? So whenever you are writing the batch first equal to true, so it will just return the first, it will return the batch, then after it will follow the, this will be the same. Whenever it will output will come, then this will be the same, the batch, the first batch you are just want to see. And then after hidden size you want to keep hidden size, that is the timestamp, you can just say. And then after input size. Okay, this way the output will be, if you are specifying the batch first equal to true, because you want the, you already done in the ANN LSTM, already you have seen the batch, you are just writing the batch, then after followed by height and width and number of channel, followed by that. Okay, the same way what you have to specify, you have to specify batch first equal to true. By default it is false. Okay, so whenever you are specifying batch first equal to true, then output of that particular LSTM will be the first way, it will go for the batch. Okay, what will be the batch, and then after it will follow to the hidden size, and then after it will follow input size. Okay, so I don't need, you don't have doubt in this, I think it's really easy. And after that what you have to just create, you have to create one fully connected layer. I'm just creating one LSTM layer. Okay, LSTM, then that has two layers. Then after sorry for that, then after that you are just creating the fully connected layer, that already we are seeing. So what you have to just write linear, and then after that you have to pass the number of you have to pass the number of hidden size. Okay, so hidden size into what will be, you will pass the sequence length. Okay, so what do you mean by hidden size into sequence length? Okay, so you have to pass these things, and what will be the output for that? So the sequence length is basically, you can just say how many sequence length you want to keep. I think we have not defined the sequence length. You can just define here also, no need, no problem. Even you can pass the sequence length as 21, 28, because 28 input size will go, and then after the total 28 cross 28 we have. So 28, the first rows it will go 28, that is the input size, okay, you are keeping for the RNN. Then after followed by 28, 28, 28, okay. So that is just the sequence length, okay. So you are just keeping the sequence length here. So you are just keeping the sequence length here. You are just, sorry for that, sequence length, if we are just keeping, we are just keeping as 28, okay. So no doubt in this also. So here what you have to pass here, whenever you are just creating this thing, so how many layer in that. So what will be the last layer? The last layer you are going for the fully connected layer. That's what you are going to use. That will be the what will the sequence length into the hidden size. That will be the output, okay. So what you can just do, sequence length into hidden size, okay, hidden size, okay. So this will, and then after the, what will be the in output number of neuron, that will be the, depends upon number of classes you are going to use, okay. So what does mean it, you already seen this thing, but what does it mean, what I have just created this one, okay. So this is basically that sequence length you are just taking into hidden size what you are going to use. So what will be the output for that? So actually the main thing here is that the number of sequence length you are going to use, it's a 28, okay. So 28, and then after you are going to use the basically what you are going to use, first of all sequence length, then after you're going to use the hidden size. So what is the hidden size? You are just specifying here the 256. That is really huge. You can just even keep it light also, but no problem for that. So you are just keeping as the sorry for that, you are just writing as the hidden size into sequence length, okay. So I don't think so you have problem in this. So it's quite clear. Now after that you have to define the forward method, okay. The forward method you have to define, and here you have to pass the basically the self comma the images you want to going to pass, okay. So this thing is really easy. You already have make the constructor for that. You already have the super method. You already have the hidden size. You are just initializing this hidden size and number of layer. You are going to use this thing in the forward method. That's why you are just initializing this two, okay. And rest you are not initializing this one, okay. And then after that you are just making one LSTM layer. You are using this LSTM layer, and it takes three parameter. That is the input size. What will be the input, the first input to that particular LSTM, you are just giving as 28, okay. That, and then after what will be the hidden size, you already define here, that is the 256. And what will be the and you are just specifying like batch first equal to true, okay. So batch first equal to true means whenever the LSTM will return the output, that will be the shape of batch size and hidden, followed by hidden size and input size, okay. That will be the shape of that, okay. Then after you are just following with the fully connected layer, that you will, that is the last input what you are, what you will get from the last LSTM layer, okay. That will be your, you will fit to that first fully connected layer. That is you only one fully connected layer you are defining. So that will be the last is the hidden size. What is the total hidden size? You are just specifying 256, okay. And then after sequence of the length, all the 28 sequence of the length, you are just multiplying so that it can directly fit to that particular, you are just keeping this particular to the input layer, and then after you are just number of layer you are keeping in the output layer, okay. So you are just creating only one fully connected layer. So I don't think so you have problem in this. So now what you can just do, now you have to make, you have to initialize the hidden state and cell state for this particular LSTM, okay. Because the hidden state and cell state previous, the first time it will be the zeros, then after it, whenever it will go for the second hidden second sequence, then third sequence, then fourth sequence, then you will have some hidden state and cell state, memory state. So that, but initially you are going to directly feed the data, so there is no previous input. So at that time you have to initialize with the 0. So what you can just write here as 0, you can just write here, and you have to just initialize with the torch.0, okay. So you can just write torch.0, and here you have to pass self dot number of layer you are going to take. So number of layer we are keeping as 2. It takes the first parameter, that is the number of layer we are taking as 2, and then after you are just, you have to specify the the batch size, okay. So batch size, it is whenever you will do the image dot size, okay, the first thing it will appear the batch size. The first thing it will appear as the what you are going to use here in the batch size, okay. So what you will write here for the batch size, you will just mention as 0. The first thing, that is the batch size we are already have taken, I think 64 we have taken, that this will be the pass here, okay. And the third thing is that you have to say hidden size. Okay, so what will be the hidden size for that? Okay, cell dot hidden size already you have defined. So this is the same way you have to write for this particular cell state. Okay, the same way we have to write for the cell state, but change from S0 to C0. Okay, so yeah, this was the, you are just initializing the hidden state and cell state in this particular LSTM layer. Okay, so then after that, what you are going to use, you are just writing the output. Okay? So you are just writing the output. It will just see the self.lstm will return the two things. One will be your output, and other you don't want that particular bit, because it will give you the all the hidden state what was the output. So you no need only the last what is the hidden state, what is the output you are just mentioning, so that you can directly fit to the fully connected layer. Because what will be the last output of the LSTM, that particular you want to take and you want to fit into the first fully connected layer. That's what you are going to use. Okay, so for that, what you are going to write here, you have to just create self.lstm. Already you have just initialized before this, already you have just created. And then after that, you have to pass the data, that is the images. This is the data over. And then after, you have to say hidden state and the cell state, hidden state comma cell state, in this tuple form. Okay, what I'm just writing here, you have to write here. Okay, cell state. So what you are just doing here, so it will just, LSTM will return two output, two things. That is the output what the LSTM has given you, the output, the last layer, so that you can directly fill to the fully connected layer. And this thing is the all hidden state what you are getting the outputs for that. Okay, so here, and then self dot, that you don't need this one, that is the useless for this particular problem. And then self.lstm, it takes two parameter that already I've said, that is the image. You are just directly passing this, and then after, what you are going to use, then after, you are just going to use hidden state and cell state. Okay, so you are just passing the hidden state and cell state. Initially you are going, you are just initializing as a zeros. Okay, then after that, you will just reshape this thing. Okay, so that you can directly fit to the fully connected layer. Okay, so output you are just getting, from output, or you want only the last one, the output you are getting for the all the 28, or the all the 28 sequence lengths, and the last sequence lengths you will keep to directly to the fully connected layer. Okay, so what you are going to write, you want to reshape this thing. So you can just do reshape, and then after that, what you are going to reshape with output, sorry for that, out dot, what is the shape of this, and you want only the first, that is the batch, the last one, and you want only for the last, this what you want to say. Okay, so output dot save will just return whenever you will do the training part, you will able to see. So output is basically, it will return into batch size. So what I've said, batch size, hidden size, and the input size, what it will just return. Okay, so from that, you want only the batch size, and then after, you are from that batch size, you want only the last. Okay, the last layer for that, so that you can directly fit to the fully connected layer. Okay, so yeah, it was really easy. And then after, you have to define self dot fully connected layer. That's the, already you have just created, just pass this out, that's it. And just return this, and this is your, you have created this, this is you have created the LSTM or RNN model. Okay, so you will see this thing more detail whenever you will do the sequence of the data that I will just upload. We will do some projects related to the LSTM or RNN, so at the time you will see more thing about the RNN model. Here I'm just using for the images of data, and images of data you are not going to use that much for the RNN, because at that time you will get, your CNN model will give you higher accuracy as compared to the ANN or RNN. So that's case, you are just, RNN is only working the best, working on the sequence of the data. So you are just fitting the sequence of the text, so they, and then after, on the basis of the sequence of the text, they are just predicting the what will be the output on the previous cell state. Okay, and previous you have cell state and memory state. Okay, so this is what the RN we have just created. I will go in the brief again. This is what you have done. Then after, you have just make the constructor. Then you have just initialize the hidden state number of layer. Then after, you have just create the LSTM. Okay, in LSTM, you are just passing the input size, hidden size, and number of layer, and you have to specify batch first equal to true. If you are not specifying, then batch will be the in the middle one. Okay, so you are just specifying batch first equal to true, it will just give you the output in the shape of batch size, hidden size, and input size. Okay, then after, you are just creating the fully connected layer, so that you are able to train the model, so on the basis of number of class you have. Okay, then after, you are just creating the forward method, and you are just passing this image. Then you are just initializing the cell state and memory state and hidden state for this particular LSTM, because the first time you don't have any previous input, so that's why you are just initializing all things into zeros. Then after you are just you are just using self.lstm, what you have just initialized here, and it takes two parameter, that is the image and cell state and memory state in the tuples form. Okay, that will give you the output, and this is the all the sequence, all the hidden state, what was the output. So you need only the output, the last output. Okay, and from the last output you want the last sequence length, so that you can directly fit to the fully connected layer. What you are going to write here, -1. Okay, the last one, and then after you will get some output. Okay, this is what was the RNN. So you can just make the object for that, you can just write RNN, that's it. Okay, so this was the ready to what I have done. I have to just write capital N, no small n. Okay, just run this one again. I hope so it will run. Yeah, so this was the, and you can just see the parameter of this. If I'm just writing printing RNN, so what you are going to see this is here the parameter. Okay, so this really small, but yeah, you are using two layers in this LSTM. So that's this was the how to create a RNN model. In the next video we will going to see, we will train the that is ANN model, we will train the CNN model, we will train the RNN model. Okay, so we will see the result of every model what we have done till now. So hope so you are clear with that, and if you like our channel, please subscribe our channel. That's it, thank you. Next generation channel. In this particular video we will look at how to train our ANN model, how to train our CNN model. So in the previous video we already have seen how to create the RNN layer, how to create the CNN model, how to create the ANN model. Okay, you have gone through these three particular model, how to create, and each and every step I have explained in the more details. You can even watch, if you have not watched that particular video, how to create the model, you can just go, I will just give the link in the description. You can just directly go to the playlist of this particular PyTorch, you can just directly see all the video related to the PyTorch. Okay, so in this particular our main focus is to build our training function, so that it can train the both CNN model and it can train the both ANN model. Okay, so because you are just creating the model is only the difference, but the training function for the both ANN and CNN will be the same. Okay, so what you are going to write before creating the training function, what you have to just say what loss function you are going to use, what optimizer you are going to use. Okay, so you can just initialize this thing. Okay, you can just write loss function, and you have to just write here, and you are just writing from nn dot cross entropy loss. This is the loss function we are going to use in this particular model for the both CNN and ANN. Then after you are going to create the optimizer for that. Okay, optimizer you have to write, already we have just imported this optim. From optim you have to use stochastic gradient descent SGD, and then after you have to pass the model dot parameter. Okay, parameter you have to pass, and then after the second thing it will take the learning rate. Okay, so learning rate you have to keep 0.001. Okay, so you have just initialize the loss function, you have initialized the optimizer. Now you have to create a function. Okay, you have to create the training function. Okay, so in that you are just passing the model, that can be ANN or that can be CNN model. Okay, and then after you are just passing the loss function for that. Then after that you are passing optimizer. Okay, and then after you are passing the number of epoch you want to take. Okay, so this thing it is clear for you. So it's like really you are just taking these sorts of parameter. Okay, so now what you are just doing, you are just iterating through all the epoch. So you have total 10 epoch you are just taking, you have just taking. So what you have to do, it will just loop through the 10 times. Okay, so 10 epochs means 10 times the forward propagation and the back propagation the model will do. Okay, so during the training phase. So what you are just writing here, so it's really easy. And then after that, before doing this one, we have to also visualize this particular model. Okay, so if you want to visualize the curve between a training or testing, how they are just increasing on the accuracy, and based on the loss how they are just decreasing, where your model is overfitting or underfitting. Means overfitting means your training accuracy is really high, but if whenever you're going for the testing accuracy it's really low. So at that time you can say your model is overfitting. And if the both the training accuracy and the testing accuracy is going down, so you can just say that particular model is the underfitting model. Okay, so for visualizing you can just do the visualizing with the help of matplotlib. For that you have to create a list. Okay, you can just write training accuracy, you can just write training accuracy, training, yeah, you are just creating an empty list for that. All the, if after every epoch you will see the what is the training accuracy, and you will append in this list. Okay, similar you can just write the training loss, and you're creating the list. And then after testing accuracy you are just creating the list, and testing loss. Okay, testing loss, and you are just creating the list. Okay, so I don't think so you have doubt in this. And then after, you are just iterating through all the pops. So for that, okay, so for that, again, you have to just write here training loss. Now don't write training loss, because it will overwrite what you have created the empty list. Why I'm just writing train loss? So you can just, you want to see after every epoch, you want to print that particular train loss and train accuracy. So you will see how your model is increasing the accuracy and decreasing the loss. Okay, so for that, you are just initializing from the float value, and then again you are just going for the training accuracy, and you are just initializing from the 0.0. Okay, now it's clear. Now you are just saying to the model, this is in the training phase. Just why you are writing model.train means you are just in the training phase. That's it. Okay, now what you are going to use, you are just iterating this particular images comma labels in train loader. Okay, so you are just iterating this thing. What does it means? So what does it means you already have the, in one batch you have divided everything into batches. You have 64 images in one batch. Okay, so you have 60, you have, how many batches you have divided can have 64. So you are just taking the first 64 image, you have the images of that, and you have the label of that, and you want to see, and whenever you are just feeding that image to the model, so what model has been predicted and what actual it for that particular 64 image, then you are going to back propagation, and then after you are just updating the weight. So you are just doing everything into batches form. Okay, and you are using that for optimizer, you are using as a stochastic gradient descent. Okay, clear for you? So what you are going, what you can just write here, optimizer. First of all, what you have to say, optimizer the zero grade. What does it mean? So whenever you are just setting zero grade means you are just resetting the gradient, so that the first iteration, whenever you are getting some gradient, so it can, whenever you are doing the second time looping this thing, so it will, what was the previous gradient, it will just take as the input for that. But for now, what you are doing, every iteration you will have the, every batches of image you will have the different gradient, so that it can able to update the weights. It is not dependent on the previous. That's why you are just going, you are resetting this, resetting, or reset, you can just write reset the gradient. Okay, so I don't think so you have doubt in this. Then after that, you will just pass the, you will get some output, you will pass the images to the model. Okay, so you can just directly write the here, you just pass the model. You are not writing model dot forward, because this is the basically the forward method. It is basically used for the forward propagation, this method. But whenever you are just writing model, and then after you're just passing the image, so by default image PyTorch will figure out that you are using the forward method. Okay, so no need to call model dot forward. Okay, even you can just call model dot forward, it may run. Okay, but the thing we are going this thing, because in the backend there is callbacks and something they are just implementing by default, so you don't have to go that much deep. You just take that particular model, what you have, just make the object of that, and just pass the images. Okay, so yeah, this was the basically, and then after you will get some output. Then after you will just see the loss. What is the loss? You already have the loss function. Okay, then in that particular, what is the output, what the model has been predicted, and what actual your label has. Okay, so you will see in the, in basically you are going to use the cross entropy loss. So cross entropy loss, by default they will use the softmax activation function. First they will convert everything to probability form. Then after it which particular out of 10 neurons, you have 10 neurons in the output layer, and which neuron will have the highest value, highest probability, that particular model has been predicted, and then after it will match with the actual one. Okay, whether you have, then after, what if you have the higher loss, then it will go to back propagation, it will just update the weights. Okay, the way it is going to go, that's okay, how you are just going for that. Then for that, how you are just calculating gradient, so with the help of loss dot backward. Okay, so whenever you are just writing the loss dot backward, you are going to calculate the gradient. That's it. Okay, it's calculate the gradient. Okay, so they are really easy. Then you have just passed. Then after you have to use, you have to just apply for all these particular optimizer. Okay, so optimizer step means you are just updating the weights for every. Okay, so every you are just updating the weights. Okay, updates the weights. Okay, so you have the update the weights. What you are going to write here, you have the loss, you have the you have done the back propagation, that is you have just calculated the gradient, and you already have the optimizer dot step means you have just update the weights for every features, or what the weight you have in the previous one. Okay, so that thing that was really easy. Okay, now you want to see the loss. Okay, you want to see the train loss. So how you are going to see the train loss, you are just, you doing plus this, after every iteration you are just adding this thing into train loss. Okay, for that you are just creating loss dot item. Okay, So from loss you want only item. It basically means you are getting some loss from here. Okay, now you are just adding to what was the loss we have initialized with 0.0. So it will add up in this again. In the second iteration will go, it will add. So it will add for the of the only one epoch, so that after completion of one epoch means this is the iteration is going. Now how many iteration it will go depends upon you have the data set. You have 60,000 images, and you have, and each and then you are dividing them into batches. Means the first 64 image it will go. So 64 image it will take, and it will iterate up to, you can just divide 60,000 divided by 64, that many iteration it will go do this particular. Okay, and you will get the loss of that. So you are getting the loss and you are just doing this thing. Okay, so you do, I don't think so you have doubt in this. Then after what you are just doing this one, then after you want to see the prediction part. Okay, what the model has in prediction and what actuality you want to match this thing. Okay, so you can do this thing also. What you have to do, prediction. Okay, prediction, what the model has been prediction, how you will do this one. So you will just write torch.argmax. Okay, so argmax is basically, it will return you the index of that particular in which you have the highest probability. Suppose you are using, you have three neurons. Okay, one, two, three, and in this particular three neurons, the first one you are getting the higher probability as compared to the two. So it will return as index as 0. Okay, so this is what torch.argmax it is doing, and you are just passing the output. That is the output, that what you are just getting from that, and then you are just passing dimension as 1. That's same as it is if you have done in the pandas as x is equal to 1. So you are doing across the column. Here everything it in the vertical way, so you are just doing for the output layer. Okay, so this is what the prediction you have done. Then after you will append this thing into train accuracy, what you have just initialized here. So plus equal to, if that particle prediction, if your particle prediction equal to labels. What does it mean? Means if your particular prediction, what the model has been predicted, and that has been equal to labels, then you are just summing of this all thing. Okay, you are just summing of this, and then after you are just, and from that particular you are just want that particular item, you don't want in the list form. Okay, so you are doing this one. So you are from this particular you are getting the accuracy. Okay, so it's like really basics for Python. It is, so no need to go in depth is what it is doing. Dot sum dot item. Okay, so you have done this thing for this particular accuracy for the training part. This is the training you have done, but again you have the training accuracy and training loss, you want to append this thing. Okay, for that what you have to write here, you can go backward, so that for the every epoch you can just append. Okay, so what you can just write here, training accuracy. Okay, dot append. How, what you will just write here, you will just write here what you have get the for this particular train loss. Okay, sorry, train accuracy. So train accuracy, after summing of, after running the every iteration, you will get some accuracy. Okay, so you are just writing this thing, and then after you are just dividing the length of total, you have the train set. You have already, you have defined the train set. Means if you have total 10 digit, out of 10 you, if your model is predicting 8 as a good and rest 2 is not good, then you are just saying 80% is your training accuracy. That's what you are just doing here also. Okay, train set. And similar, you are just going for the training loss. Okay, you are just writing for the training loss, and that append, and then after you are just passing the train loss, but here you have to divide with the train loader. Okay, so why we are just dividing with the train loader, means you are just dividing everything in the batches, because after, see what you will be, what it will just model will give you the return, what will return, because you have 64 images in one batch. So model will calculate the 64 loss, and they will divide by their 64 the batches. Okay, that's why this way the loss it is going. They are just taking 64, then they are just take then after they are just calculating the loss, what you are getting the loss, then it will going to back propagation, then after it is updating the bits. Okay, so it's already has been taken 64, so no need to go for the trains, and just you have to write here train loader, length of train loader. Okay, clear. So you have done the training parts, is really clear. Then after, if you will go for the testing parts, again we will do for the testing part also here only. Okay, so in the testing means, in during the validation part, you are not going to change the weight. Okay, you are not going to change the weight, you are not going to calculate the gradient. You want to see after every epoch what will be the accuracy by that. Okay, means what is giving the accuracy. If the model is trained, then on doing the first validation, what is the accuracy, during the second validation, what is the accuracy. Okay, so for that you are just saying eval mode, means you are now in, not in the training mode, you are in the evolution mode. Okay, that means you are in the testing mode. Okay, eval mode. Okay, so for first of all, what you are going to write here, again you will just initialize with the train loss something 0.0, you will initialize, and similar you have to initialize the train accuracy as 0.0. Okay, So now with after that you have to write for with toss dot no grade. What does it mean? Means you don't want any gradient for that. Okay, it's like toss dot no grade, no grade. But showing me like this, no need. Okay, so what does it mean? Toss with toss dot no grade basically means you don't want any gradient for that. Okay, so for that you now you want to just loop through the same way you will just write everything, but in the case you will not write the loss dot backward and optimizer dot step and optimizer dot zero grade. Means you are not calculating any gradient, you are not updating the weights of this during this, you are just checking on the model, that's it. So sorry for that. For images comma labels you are just going to write here, give me 1 second. Water. Okay, so for images comma labels in you will write in the test loader. Okay, so what we have already defined, um, test loader, this one. Okay, and then after the similar way you have to write here output. Okay, so output equal to model, and then after you are just passing the images for that, and then after similar way you will just calculate the loss, everything will be the same way. So loss you will just write here the loss function, you already have the loss function, you are just passing basically output comma labels, you're just passing this output comma labels, and similar way you have to just you have to just set for this particular test loss. Okay, the test loss, what will be the test loss plus equal to a loss dot item, that's it. Okay, the what you have done the above, so no need to explain the again. Only in the difference between them is that you are not going to update anywhere, that's it. This is the main difference. Okay, the rest how you are just calculating the loss or prediction, it will be the same for that. Okay, so what you are just writing here the same torch dot you are just going to torch dot argmax. Okay, argmax, and then after that what you are going to say from output, from that then after that you are going to for the one dimension. So already this thing I have explained about the prediction, means from the torch it will give you the index of that particular. Okay, so from that which particular neurons has been fired, means which has the highest probability that particular neuron will be fired. Okay, so you are already clear with this. Then after that what you are going to use, then after you are again you are just seeing the accuracy of this. Then after that you can just do the same as it is, you can just do plus equal to if your prediction, if your what the model has been predicted and what it is actual match with that particular what actual model has for that. Okay, then what you are going to do, you are just summing of that, and from that you want only the item, that's it. You are going to this. So that's it for this, and then after that what you are going to use, you have calculated the loss, you have the train accuracy, you have the test accuracy. Okay, so now you again you have to append this thing in this what we have already have defined, that is the testing loss and testing accuracy, so that you will able to visualize this thing. Okay, so this is what you are going to see, and then after that we will see this thing. So what we are going to write here, testing accuracy dot append, what we have done the similar way we have to write here test accuracy divide by length of test set. Okay, test set the similar way we have to write for this particular loss. Okay, testing loss dot append. Okay, you will just write here test loss, okay, divide by length of test loader. Okay, you have to write the test loader. Okay, so I think you are clear with this. Okay, you already append this thing. Now what you have to do, now you have to print this thing. Okay, so you want to print this after every epoch, you want to see what is the accuracy, what is the loss for that. So I'm just writing this thing as a placeholder, then after you're just writing training accuracy, then after this is your placeholder, and you want only up to plus 2.2 f, means basically means the two floating value, up to two floating value you want, that's it. Okay, and then after again you are going for the testing accuracy, you want to see the testing accuracy for now only, how they are just decreasing, and you are just writing the two web the similar way you have to write the training loss training loss, and then after again you have to write the up to two floating value, you want this one two floating value again you, and then after that again you are just writing testing loss. Okay, testing loss, and this is what you are going to write here, and then 0.2f. Okay, so this already you have just done. Then after that you want to print this thing, that is forward, just do, and then after you want to go start with the epoch plus 1, because by default it will start with the 0, just mention epoch plus 1. And then after that, what is the training accuracy? To training accuracy, what was the accuracy divided by length of train set. Already we have seen this thing. And similar way you have to do with the test accuracy divided by length of test set. Okay, test underscore set. And similar way we have to do for the loss also. Okay, so training loss is already we have defined train loss divided by length of train loader. Okay, train loader already I've seen why we are going to use the loader for that. And similar way we have to go for the test loss also. Okay, test loss divided by length of test loader. Okay, clear with that? So I don't think so you have doubt in this. It was really easy. So you have created this particular function. Either you can just check. If you will do any mistake, we will see this time. No need for that. But the main focus was that you have created this particular training function. In that particular training, you have done the both the training and validation both. Okay, you can just train and validation function you have just created. Okay, so this part you are going for the training part, and then after this part you are going for the testing part. Okay, so same after every epoch you are going to see this thing. So let's run this one. Okay, so hope so it will not give the error. Why during the first it is giving the error. So train accuracy is what is saying there. Training accuracy, what I have done. Oh, double. Okay, sorry for that. Okay, you have just it run. Now what you have to call? You have to call the model. Already you have this ANN model. First we will see the what is the accuracy of the ANN model. Okay, so for that you have to call this training function. You already have the model, that is the ANN model you are going to pass. You already have. Then after that a loss function and then optimizer. Okay, so loss function optimizer. So what you are going to write here, loss function, you already have created the loss function, you already created the optimizer for that. Okay, and then after by default epoch is 10, no need to pass. If you are passing 5, you can just see, just run this thing. Hope so it will give you the output. So for the total we have just used the 10 epoch. Okay, so for 10 epoch it will take some time to train the model, 10 epochs. So you are able to see you have get the training accuracy, testing accuracy, and then after training loss and basically the testing loss. Okay, so what we are going to see one thing, what you can just do this thing, you it will take some time for that training part. Even if you have done any mistake, what you can just do, you can just recheck this one. Okay, so what we have done, okay, so we have just trained this particular model. Okay, so we have just trained this particular model, we have just taking the for list above that. Then after that you are just looping through the all the epochs. Okay, so you are looping through the all the 10 epochs. Then after you are just initializing, so you are just initializing train loss and train accuracy. Okay, so what is the train loss is basically 0. You are just initializing what train loss and train accuracy. Then after you are in the training phase. Okay, then after you are just looping through for image comma labels in the train loader. Okay, you have the train loader, and then after you are just optimizing this particular gradient for that, and then you are passing these particular images to the model. Okay, then after you have the loss for that, you have loss dot function, means you have the output comma label. In that output comma labels you are just passing what the model has been predicted and what actuality is. Okay, and loss dot backward, you are just calculating the gradient for that, and optimizer step you are just updating the weights. You are just clear till now. Then after the train loss we already have initialized this thing, train dot loss. In that you are just adding the loss dot item. Okay, and then after for the prediction, okay, you already have the prediction for that. The prediction equal to toss dot argmax. Okay, just passing the one for that. And then after train accuracy, you are just saying what will be the train accuracy for that. Train accuracy is equal to prediction equal to label then dot sum dot atom you are going to use for that. Okay, so this how you are just calculating. And then after training accuracy and training loss, you are just appending this basically for the, you want to visualize this thing. Okay, so you want to visualize, so after every epoch you will see, you will get some output. Okay, and you are just adding on that. So I don't think so you have doubt in this. And then after similar way you are going for the model evaluation, means you are just doing the testing phase. You want to see this thing. Okay, so you are just looping through with toss dot no grade, means you don't want to check the gradient for that. I am getting the everything as same accuracy. We will see for this, don't worry for that. Oh, it's like a many time like 90, those who are beginner, they will suffer this kind of problem. Again, what I have done, I will explain you. So this type of mistake you are not going to do again. So for that, what you are just writing again, you are just drawing with torch.toCreate. Okay, so with torch.toCreate is basically that you are just saying to that particular model that this is not for the gradient. You don't need any gradient because you are not updating any weights for that. Okay, so again you are just looping through the test loader. Then after you are just passing this thing the all the images, and then you are just calculating the loss for that. The similar way what we have done. Then again you are just passing the test loader as loss dot item, and then after from that you are just writing the prediction, and then for prediction toss dot arguments you are just returning that one. Then again the test accuracy what you are getting, prediction equal to label dot sum dot item. Okay, so from that, like you already know, test accuracy dot append you are just creating, and then after that testing accuracy dot append you are just writing test accuracy by length of test loader. Basically you are doing the same as it is. What was the test accuracy divided by whole of the test set. Okay, that is the 10,000 you have in doing the testing for testing one. And then after you are just writing this particular epochs. Okay, the what is the train accuracy you are going to see, what is the test accuracy, what is basically your test loss and trace accuracy. Okay, what you can just do, restart and run all. Okay, so we will see this thing again, restart and run all. Okay, so we are going to train it, model it again. So it will, hope so it will not give you that type of or you already have the train set, test set, you already created this model. Okay, you have everything for now. Okay, so this after that we have not used the softness for that. Yeah, no need for that. And even we can just see you are just going for the ANN model first, so you can just see this type of things. Yes, we are going to use loss as we are going to use this basically learning rate is 0.01, no problem for that. Yeah, and again what you are just going to write here, so what you can just create here, loss function you can just mention here. Okay, so it may give it, now it will not give you that type of error. Okay, so only for the ANN model you are just passing. Okay, so what you can just do, restart and run all you can just do. Okay, and now you are able to see now what will be the output for that. Okay, so you are just restarting this all everything and you are just running all. So you can just see it is running, it is importing the first. Okay, oh it is done till now, it's done now. It's during the training phase. What will be the accuracy we are going to see. So yeah, hope so it will give you some output. Yeah, you are just seeing this one, training accuracy at 0.15, testing accuracy at 0.18, and you have the loss, you have the, and then this how the training accuracy and testing accuracy is increasing after every epochs. Okay, so what was the problem in that, you will just figure out this type of problem it is done by the beginner. Okay, so the thing is that what I have just done the same thing because I want to guide you this thing in the proper way, because whenever you are just writing this model, every time whenever you are just creating the object of the model, just create the first, so that you are just passing this model as a parameter. This stochastic gradient descent is the most important step. With the help of gradient descent you are able to change the weight. This is the most important things. Okay, with the help of gradient descent you are able to change the weight. Okay, during the back propagation. So this is a really important step you have to do. And in the model dot parameter you are just you have the weights of every parameter and you are just changing the weights during the back propagation. And so stochastic gradient descent, they are just calculating the gradient with the help of that, means w new equal to w old minus learning rate into gradient. What is the exact formula you are just saying. Okay, you are getting something. Okay, I have mentioned only the 10 epoch. Okay, so no for that you are getting the much low accuracy, but you can just increase your epoch as 20. If I'm just doing as 20 times, so it may give me a good accuracy for that. Okay, so again what you can just do, just copy this thing. Now you want to see for the CNN model you are going to use. Okay, for CNN model what will be the output we are going to see, let's see. And just train this thing, and then after what will be the, see what you are going to see the output. So again you have just trained this thing for the ANN model, because you have just created the object for the first ANN. Now you are just training the similar way for the C convolution neural network. Okay, for the CNN model, I don't think so you have doubt in this part. So I'm just going from each and every step. If you understand this particular training thing, so this thing it works on the same for the ANN also, for the CN also. Those who are beginner, they will just think that ANN will ANN function of the training is different as compared to the scene. There is no, if you are, unless you are using any pre-trained model, okay. So pre-trained model, that is ResNet, Inception Net, we are going to see this thing in more detail, okay. So that are really different thing. Pre-trained model, even we will do with the help of PyTorch, we will do many project for that, okay. In the next video we will see how to visualize this particular model, okay. We have trained this particular model, we are see every time. And then also the second thing is that already I have said to you that a CNN convolution neural network will give you the higher accuracy as compared to the any ANN model. Why? Because because the convolution neural network only deal with the images, and this whole the images where the image object it is in that particular image, it will focus and that at that part only. It will just reduce the what you have useless pixel, okay. I can just think that you have one image, just think that you can just visualize you have one images, and in one images any person, it is inside of that images. So the side corner only the particular CNN will focus, okay, and the rest it will be removed. The pixel is useless pixel, you want to concentrate where the person is, that's it. But in the ANN it is taking every pixel, it has the weights, and you are just feeding everything into a ANN model, okay. So that's why it is giving the low accuracy as compared for the ANN model. But CNN will 110% it will give you higher accuracy as compared to the ANN model, only in the case of images and data you are just going to use, okay. Okay, so this was about the training period and how you are getting, and each and every step I have make you clear, even I have the second for the second time, and what the why you are getting the same loss, same loss, this type of problem you are facing this thing, okay. So that's why again I have showed you that thing, and again from that you are getting the ANN accuracy and AN loss. So in the next video we will see, we will do the visualizing part, okay. So visualizing part is really more important thing. So you will see after every training accuracy and training loss, what you are just seeing things, okay. So what we can just do, we will continue this thing in the next class and next video. So it will take some time to train the model, okay. So in next video I will just show you how much accuracy I got in this particular video, okay. That's all for this video. If you like our channel, please subscribe our channel. Thank you. That is AI next generation. In the previous video we already have gone through the training part of the ANN model, we already done the training part of the CNN model, and you are able to see that CNN model is giving a higher accuracy as compared to the ANN model. So whenever you are dealing with the images of data, so at that time 100% you will get, not 100%, you can say 99.99% you will get the accuracy, more accuracy for the images in the CNN part than of the ANN part. Why we will get this thing, already I explained this thing in the previous video. So hope so you have watched the previous video. So in this particular video the main focus is to how to plot the particular training curve, testing curve, or their accuracy, their different between the accuracy, like how you are getting the training accuracy and how the training accuracy is increasing, how the testing accuracy is increasing, okay. So whether you are you have the problem of overfitting or underfitting, so you can just see, you can visualize this thing, okay. What you can just do, you can just see in the previous what we have done, you can do the two things. Either you can just create, you can just return of this all the four lists in here, and you can just create the function. Other things is that what you have to do, you have to just write the same training period, like plot, you have to just write plot x train and y train for the here only. So whenever you will just run this function, this particular function, after training it will just plot the same as it is, okay. So you are just writing everything into one function, so it will be like more clear for you. So what you have just doing, so first of all we will train plot, basically we are going to plot, okay. So plot training, okay, training curve we are going to see for plot training, and also we are going to for testing, okay. Plot training versus testing, we will see this thing. So first of all what you are going to see, so first of all you will just say the title, okay. So what is the title, you are just training this particular training curve, okay. So you are just training this particular training curve versus testing, we can just say, okay. So you will see how after every epoch you are just seeing, means training and testing, you are just plotting training and testing with respect to the epochs, okay. It makes like sense, okay. It makes this sense. So what does it means, that I'm just plotting training curve and testing curve, and after every epoch in the same plot. So you will able to see after every epoch how your training accuracy, how your testing accuracy, it is increasing. So okay, so if your testing loss is decreasing and training accuracy is increasing, you will say that is the problem of overfitting. And if the both accuracy is decreased after every epoch, then you will say that is the problem of underfitting, okay. So that's we are going to see, okay. Don't worry for that, okay. So this is the title you are just drawing, and then after that you are going for the plt.plots, okay. So plt.plot, you already, the first one is the x-axis, you already have the range or range of epochs we can just keep, okay. And then after that, what you have to mention here, so you have to say which particular training you are just doing, whether you are just going for the training curve, that is particular, this is the x you have passed, and in the y particle you will put the training accuracy, okay. So we are just seeing this one only for the accuracy part. You can just write here accuracy and you can just give the label of that, okay. This is the training accuracy you are just plotting for that, okay. Training accuracy, okay. The similar way you have to plot for the testing accuracy, okay. So this particular graph is for the training and testing accuracy, okay. So yeah, you can just write the testing accuracy, and then again you have to give the label of that, and you have to just give the label test, it is the testing accuracy, okay. So you will able to see, okay, with the help of legend, okay, you will just write plt.legend. Why I'm just writing this one only to see the labels, you will see in the top right position, okay. And this is what you have just written here. So then after that, even you can just give the x label and y label. If you want x label, you can just give as epochs. After every epoch you are seeing some accuracy, and then after you can give the y label, okay, y label. And then after in y label, what you are seeing, training, what you are just seeing, training and testing, okay, training and testing accuracy, okay. So it's no problem for you, and just right after that plt dot so, okay. So you will get in the same plot, you are just plotting the training curve for the accuracy, for the both training accuracy and testing accuracy, okay. I'm sorry for that. One second. Sorry, I have cough and cold. Sorry for that. Now we can just move to the plotting of the loss, okay. We already plotted for the training and testing curve, training and testing accuracy, you can just write here. And now we will plot for the training and testing loss, okay. Training and testing loss, we are just curve, you can just write curve, it's not curve, okay. So it's like the same thing, you can just write here plt.plot, you can just write so first of all you can just give the title, it's like good. And you are just plotting for which, you are just plotting for the training curve. Training curve, why I'm getting this here? Wow. It's really, I'm feeling too much cold. To training curve, curve and testing. Why I'm writing curve here? Training accuracy and testing, training accuracy and testing accuracy with respect to epochs. Here you are just writing training loss, testing loss with respect to epoch. Okay, that's it. You don't have to write too much complicate. And then after you have to plot the plt.plot, you have to write here, and you have to plot with respect to range. After every range means after every epochs, after every epochs, what you are seeing, how your accuracy is how your loss is decreasing, okay, for both training and testing phase, okay. For here you are just writing the training loss, and then after you are just giving the label for that, okay. So you are just giving the label as this is the training loss, and similar way you are just plotting for the first of all you will just write the length for the epochs, and then after you are just plotting for the testing loss, okay. And testing loss, again you will give the label for that, this is for the testing loss, the same. And then after you will do the plt.listen for the label, and then after plt.x label, okay, x label, this here you will just write in x label you have epochs, and in the y label you have basically the training and tra ing and testing loss, okay. I don't think so you have done. Then after you just write plt dot so, okay, that's it. This is the curve you can just plot. This is how you are going for the training, or you are seeing the accuracy for the both the training and testing, and you are seeing the loss for the both the training and testing. Just run this particular function again. So see this particular model again, it will take 10 epochs to train this particular model. So during that time I will just make you clear about how you are just doing for the training period. How yes, wow, x and y must have first dimension but have separate. What I have done this thing previous, it was like okay, x and y dimension. I have done something silly mistake. Okay, so what I have done, what I can just amuse. What this error? Wow, value error. X and y have the same first dimension, but the bet have the shape of 10 comma 1 comma 0. What the heck is that? Or you have model, you have loss, you are just using optimizer, then after you're just going for the train loss function. Following the training period, I have done nothing else. I have done. That's it. But what I can do? You can just plot this thing after. Oh, okay, okay, okay. I'm just plotting everything inside the this. Okay. Okay, now it will run. Okay, sorry for that. Is basically, I think you also understand what I have done. The mistake was only the thing is that I am just writing this plot inside this particular loop. That is the epochs loop. You don't have to write inside the epoch loop. Every epoch, so why it will give you some output. Okay, so in that you will get some accuracy, then after you will plot. Okay, so that's yeah, you can do this type of common mistake. You are just writing everything inside the for loop, so you have to make outside the for loop. So after completion of every training period, so you will see the loss curve and training curve. So after every one epoch, what will be the loss and what will be the accuracy. Okay, so this way you are just getting this. After we will see it, we will wait for that, no worry, even we will not pause the video. So during that time I will explain you which particular model you have to choose in what phase. So this was, I think, the basic from part 1 to part 6 or part 7. We already have explained you how to deal with the datas, how to create the different model, how to train the model, how to go for the testing model, how to do the visualizing term. So this is the really basic thing you already have seen. If you have done this thing really well during the first phase, because they are like you can just say beginner. If you are really beginner in the PyTorch, so this is the ABCD for that. What we are just creating the model from the scratch, everything. They are really complicated model you will going to use whenever you are seeing. So this how you are just seeing, see, training accuracy, how it is increasing, and how the testing accuracy. Sometimes we can just run this one till then what is the you are just getting here. You are getting as training accuracy as 54%, testing accuracy as 57% after 10 epoch. Okay, so now you are just visualizing after every epoch how your training accuracy it is increasing. Even it is increasing, there is no overfitting problem, I think so. Okay, so it's really good. Your training curve, the orange one, you can just say this one is the testing accuracy, and the blue one it is a training accuracy. So you are able to see that both they are just increasing. Okay, so both they are increasing after every epoch. Even you can just say, you can just mention as 20 epoch. Okay, so you will get more accuracy in that. But whenever in the case will be the no increment of the training accuracy, increment of the training accuracy, and testing accuracy decreasing, at that time you can say there is a problem of overfitting problem. But you are not getting any overfitting problem. And here this how the loss it is decreasing. Okay, so how the loss it is decreasing is you are just seeing this thing. After every epoch you will see the training loss is decreasing, and even the testing loss it is decreasing. Okay, yeah. So then after we are running for the CNN, hope so it will run soon, because CNN model, you are making your model too much heavy model. Okay, so what does it mean? You are making your heavy model means it's really different from the ANN. So already if you are doing the problem, if you are just understanding how to build the CNN model, so you have learned in the CNN about how we have done everything from the scratch. Even this is my website, you can just go through my website, you can just read this particular blogs. I have mentioned too many blogs related to my website, that is of the deep learning, several deep learning. And yeah, what I can do, I can just log out, so it will be like more clear for you. Okay, so now I can just run this again. Why showing this one? Okay, so this is my website. So from here you can just learn. So I've also updated many blogs. So blogs is under progress about the deep learning, and then about the machine learning. Every algorithm you will get from this particular video. Let that things to train. Okay, at that time we can just explore in this particular website. So there also I've just doing everything, probably projects related to data science or deep learning, machine learning or Python. Okay, so before, you see, now if you are just starting the ops, I know you already know this thing, but still you should know the everything related to the ops is like the backbone for the PyTorch, because every concept what you are just creating, it is what you are using the oops concept, that is a class that you are using methods. Okay, that's already I have also written this thing. Even you can just read this thing from this particular blogs. And even if you want to read the deep learning, even for the deep learning I have written the blogs. It is under progressive or the computer vision or YOLO object detection. Even I will just create the video using the PyTorch or TensorFlow, how to detect the object. Everything we will see with the help of YOLO. So YOLO is basically used for the object detection. I have described. You can just, this is the theory part what I explain in my blog, in my website. And even what I was saying about the overfitting problem, underfitting problem, you are getting from this. Okay, so when you will have the overfitting, when we have an underfitting, I'll explain you. I have explained you here also about the activation function. I think you know about this, and about the MNIST data recognition in the Python. The same thing you will get the coding part here also, but it is really different because I have explained you only with the ANN model. Okay, so here I have explained in the video. You are getting the CNN model, ANN model both. Okay, and sorry for that, I am speaking too much fast. So, and also in the recurrent neural network, in the with the help of PyTorch, I have just do everything from the scratch. Even the coding part you are able to see. Okay, so this basically the text classification problem I have done. So this thing is that you can do many things with the deep learning. You have n number of you can do projects in the deep learning. Okay, so don't worry, it's like, yeah, we are getting much accuracy, or we are getting higher accuracy as compared to the ANN model, as already we have seen in the previous videos. Okay, this is the one, two epochs will be run. Then after we have done with that, we will see the how the training accuracy is increasing after every epoch, and how the training loss and training testing loss it is decreasing after every epoch. Okay, so this was the basically about the CNN and ANN, and everything from the scratch to the visualizing part I have explained. If you have just done from the part 1 video to part this particular video, then you have done everything, because this is the only the concept you are going to use in the Python in the whole whenever you are building the model. Okay, so you are able to see how it's good, your model is giving your accuracies like 91% is not a bad accuracy. Even what you're getting after every epoch, the accuracy is increasing. Okay, so suddenly if there will be the constant, then you can just drop that particular piece, because after that you may rise up the overfitting problem. Okay, so here also you are just saying the testing accuracy and testing loss, it is decreasing. Okay, so this was the about the visualizing part. You have done the training, you have created the model. Then after for the CNN model, you have created RNN model, you have created ANN model, you have created, you have know about the data visualizing term, you have done data loader, you know how to train the data set. So everything you have done, what you are expecting in the Python you should know. You have, if you have just watched from the part 1 to here up to visualizing part, so you are clear with the basic stuff, you are clear with the problem you are going to use for the object detection or image classification problem you are going to use. You are clear with this type of concept we are going to use. Again in the next series we are going to see some garbage classification, some we will do some projects, that is a heavy project we will do. So we will take a garbage classification problem, so that thing we will see in the next video. Okay, so I will again I will start the projects on the Python. I will upload so many projects in the Python related to the computer vision. Okay, so yeah, that's it for this video. Hope so. If you like, please subscribe our channel. Thank you.